بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على أشرف الخلق سيدنا محمد وعلى آله وصحبه وسلم. أصحاب السعادة، الحضور الكرام، السلام عليكم ورحمة الله وبركاته. نرحب بكم في رحاب الهيئة السعودية للمواصفات والمقاييس والجودة، والتي تستضيف هذا اليوم ندوة متطلبات تقييم وإصلاح وإعادة تأهيل المنشآت الخرسانية القائمة، والتي تنظمها اللجنة الوطنية لكود البناء السعودي بالتعاون مع معهد الخرسانة الأمريكي. هذه الندوة تأتي في إطار جهود اللجنة الوطنية لكود البناء السعودي نحو تطوير مهارات العاملين في القطاع الهندسي بالمملكة، وإثراء معارفهم بآخر المستجدات المحلية والعالمية فيما يتصل بالأكواد وتقنيات البناء الحديثة. وتتناول التعريف بأول كود أمريكي أصدر خصيصاً لإصلاح منشآت الخرسانة المسلحة. الآن كلمة اللجنة الوطنية لكود البناء السعودي يلقيها سعادة أمين عام اللجنة المهندس سعد بن صالح الشعيل، فليتفضل.
بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. الحمد لله والصلاة والسلام على رسول الله صلى الله عليه وسلم. أصحاب السعادة، ضيوفنا الكرام وحضورنا، أصالة عن نفسي ونيابة عن زملائي ورئيس اللجنة الوطنية لكود البناء السعودي، نهديكم تحياتنا ونشكركم على حضوركم لهذه الندوة التخصصية في مجال متطلبات وتقييم وإصلاح وإعادة تأهيل المنشآت الخرسانية القائمة كود ACI 562. ونشكر ضيفنا الكريم سعادة الدكتور خالد النحلاوي على جهوده في نقل هذه المعرفة وهذا العلم إلى السعودية. حضورنا الكرام، إن تطبيقات منظومات كود البناء السعودي هي جزء من رؤية المملكة العربية السعودية 2030 التي خطتها قيادتنا الرشيدة حفظهم الله للبناء والازدهار، وهي مرحلة تاريخية للتحول والاستثمار في بناء الوطن وبناء الفكر والإنسان السعودي بقيادة حكيمة من لدن ولي العهد الأمين سيدي صاحب السمو الملكي الأمير محمد بن سلمان حفظه الله. حضورنا الكرام، ولتحقيق ذلك قامت اللجنة الوطنية لكود البناء السعودي بإطلاق النسخة الجديدة الثانية المحدثة لكود البناء السعودي إصدار 2018 بجهود مكثفة من معالي محافظ هيئة المواصفات والمقاييس والجودة رئيس اللجنة الوطنية لكود البناء السعودي معالي الدكتور سعد بن عثمان القصبي، ومتابعة حثيثة وتوجيه من معالي وزير التجارة والاستثمار الدكتور ماجد عبد الله القصبي. إخواني، هذا المنتج لم يخرج بين ليلة وضحاها، وإنما خرج بجهود متضافرة من لجان استشارية ومن وزارات وهيئات وقطاع خاص أنتج هذا الكود الذي نحن نتفيأ الآن تطبيقاته حسب المراحل المعدة له. إخواني الكرام، جهود الوزارات، وزارة الشؤون البلدية والقروية ووزارة الداخلية ووزارة الطاقة والكهرباء بصفتهم الجهات المعنية في التطبيق، جهود مثمرة جداً في تحقيق هذا الكود وإطلاقه وإلزام الجميع بتطبيق كود البناء السعودي حسب مراحله المعلنة، يأتي تحقيقاً وتطويراً لمنظومة تشريعية محكمة لضمان سلامة المباني وترشيد الطاقة وتحقيق الاستدامة لمشاريعنا الوطنية، إضافة إلى فض النزاعات بين المتخاصمين بقطاع التشييد، حيث أن كود البناء يعتبر وثيقة تقاضي في المحاكم. وتحرص اللجنة الوطنية لكود البناء السعودي على بناء الشراكات مع جميع ذوي العلاقة في قطاع التشييد لما يخدم التطور المستمر لبناء واستكمال وتحديث منظومات كود البناء السعودي بما يخدم قطاع البناء والتشييد. وتأتي هذه الندوة بالشراكة مع معهد الخرسانة الأمريكي الACI مشكوراً تحقيقاً لهذا التوجه. ختاماً، ترحب اللجنة الوطنية بكل مقترح وبكل رأي لإثراء هذا العمل الوطني، والذي سنشهد بإذن الله أثره الإيجابي على واقع قطاع البناء والتشييد في بلادنا المباركة. وشكراً لكم، ونرحب بكم مرة أخرى.
شكراً للمهندس سعد بن صالح الشعيل. والآن كلمة معهد الخرسانة الأمريكي يلقيها الأستاذ أحمد مهنا، المدير الإقليمي لمعهد الخرسانة الأمريكي بالشرق الأوسط.
السلام عليكم ورحمة الله وبركاته. سعادة الدكتور أحمد شريم، مستشار معالي محافظ الهيئة السعودية للمواصفات والمقاييس، سعادة الأمين العام للجنة الوطنية للكود البناء السعودي المهندس سعد شعيل، الأخوة الكرام المهندسين الزملاء. في البداية في الحقيقة يعني بشكر الجميع في لجنة الكود البناء السعودي على هذه الاستضافة. واللي بدي بس أركز عليه في بعض، طبعاً أنا راح أحكي بعض الأمور بالإنجليزي أو بالعربي، راح أحكيها الكلمة هذه في العربي. معهد الخرسانة الأمريكي تأسس في 1904 في ولاية ميشيغان حتى يكون مرجع لجميع المهندسين المدنيين في مجال الكود البناء الخرساني. احنا في عندنا برزنتيشن عن الACI، فإذا تسمحوا لنا بس ممكن نقدمه يعني حوالي 10 دقائق. في حدا من الإخوان موجود بس؟ الفلاش حطها الدكتور هون. إيه. وين هذا؟ هذا اللي بشيله. مرة أخرى يعني هذا برزنتيشن راح يكون تعريف بمعهد الخرساني الأمريكي. نبذة بسيطة عن معهد الخرسانة الأمريكي. زي ما حكينا هو هذا استعراض تقريبا لبعض أهم محطات معهد الخرسانة الأمريكي. تم تأسيسه عام 1904 في ولاية سانت لويس. المحطات كلها ما راح أمشي فيها كاملة، لكن هذه أهم المحطات اللي مر فيها المعهد. إذا بتلاحظوا هنا 1941 كان هو الأول نسخة من كود البناء اللي هو 1941 اللي هو الكود اللي هو 318. أيوة. تمام. هيك تمام. طبعا ب 2004 كانت هي اللي بيحكوها ال 100 year anniversary للاي سي اي، اللي هو احتفال ب 100 سنه على انشاء المعهد الخرساني الامريكي. معهد الخرساني الامريكي تنقل بعده اماكن في الولايات المتحده الامريكيه، اخرها موجود بولايه ميشيغان بفارمينغتون هيل بديترويت. هذا هو مكان المعهد الخرساني الامريكي. الاي سي اي فيجن او اللي هي رؤيه معهد الخرساني الامريكي بنطمح انه يكون مستقبل موجود بحيث يتم استخدام الخرسانه من الجميع بطريقه يعني let me just read it in English. ACI envisions a future where everyone has the knowledge needed to use concrete effectively to meet the demand of a changing world. الميشن تبعت ACI develop, disseminate and advance the adoption of its consensus-based knowledge on concrete and its uses. في كثير من الناس بيسألوا شو هي ال ACI. طبعاً ال ACI it is a technical and educational society dedicated to improve the design, construction, maintenance and repair for concrete construction, and it is one of the largest sources of concrete knowledge over all the world. في ناس كثير بيفكروا ال ACI هي جامعة أو بيفكروها منظمة حكومية أو بيفكروها ممكن تكون منظمة تجارية. ال ACI طبعاً هي ليست منشأة حكومية وليست شركة، طبعاً وبالأكيد هي ليست شركة تجارية أو تابعة للحكومة الأمريكية، هي فقط مؤسسة غير ربحية تسعى للاستخدام الأفضل للخرسانة على مستوى العالم. فلما الناس يسألون دائما شو هي ال ACI، في الحقيقة هي ال ACI هي الناس الموجودين اللي بيشاركوا بوضع الدوكيومنتس أو التقارير أو الكودات اللي نستخدمها دائما في خلينا نحكي الكونكريت واستخداماته. أعضاء ال ACI متنوعين، ممكن يكونوا مهندسين، ممكن يكونوا محامين، ممكن يكونوا architects، ممكن يكونوا عمال، ممكن يكونوا أي شخص له علاقة أو اهتمام بالكونكريت. فال ACI هي يعني البيت الذي ممكن يحتضن أي إبداع ممكن يطلع منه. بعض الهايلايتس عن ال ACI membership موجود بال ACI أكثر من 20,000 ممبر موجودين حوالين العالم متوزعين بأكثر من 45 دولة. هون بعض البنفيتس اللي ممكن الاي سي اي ممبر ياخذها، زي ممكن اهم شيء انه الاي سي اي ممبر عنده اكسس على اكثر من 200 دوكيومنت بتشمل التقارير والريبورتس والتك نوتس اللي تصدر عن الاي سي اي. البرودكتس اللي بيطلعها الاي سي اي اهم شيء هو الكودز اللي هو 318 و562 اللي راح يتفضل الدكتور خالد النحلاوي يحكي عنه، لكن في اذر برودكتس موجوده بالاي سي اي زي السبيسيفيكيشنز او الريبورتس او الجايدز او الريفرنسز. هذه بعض التقارير اللي تصدر عن الاي سي اي. اي سيمبوزيوم يتم تنظيمه من قبل الاي سي اي او الشركاء الدوليين للاي سي اي فهو يتم اصدار نسخه خاصه فيه. برضه في عند الاي سي اي what we call it special products اللي هم الاس بيز اللي بتشرح بعض المتطلبات اللي موجوده في التقارير الاخرى. هذه اهم 3 منتجات او برودكت او دوكيومنتس للاي سي اي اللي هي الستراكشرال جورنال والماتيريال جورنال، وكمان في مجله للاي سي اي اللي هي بسموها الكونكريت انترناشونال. الاديوكيشنال اكتيفيتيز في موجود بالاي سي اي كمان كثير من المنتجات التعليميه. سيمينارز زي السيمينار اللي حضرتكم موجودين فيها الان، في publications online learning students learning، في كمان technical sessions يتم عقدها دوريا خلينا نحكي بالشرق الاوسط recently. هذه بعض الامور التعليميه اللي تصدر عن الاي سي اي. في شغله مهمه كمان بالاي سي اي، يعني بعد ما تم افتتاح المكتب هون الاغلب مش اوير فيها. الاي سي اي عندها اونلاين موديولز اكثر من 150 ماده علميه تستطيع انك تدخل عليها اونلاين تتعلم منها، تشوف شو فيها اشياء جديده وتاخذ امتحان فيها وتصدر فيها شهاده معترف فيها ومعتمد من الاي سي اي. بعض الويبينارز اللي كانت خلال الشهر الماضي مخصصه لمنطقه الشرق الاوسط اللي هي الهوت ويذر كونكريت، كان في كمان ترابل شوتنج كونكريت، وكان برضه كان في عندنا سيمينار للاي سي اي 31814 قبل اصدار النسخه الجديده طبعا. نفس الشيء في عندنا كورس اندماج بامكانه الواحد يطلع اذا ما تمكن انه يحضر الاي سي اي كونفنشن اللي بيصير مرتين بالسنه. الاي سي اي بتنزل هذه المحاضرات اونلاين ومنها فري، فبيقدر اي واحد يشوف التوبيك اللي مهتم فيها ومش قادر يحضرها بالولايات المتحده الامريكيه بيقدر يشوفها اونلاين زي ما هي. حكينا عن الاونلاين موديولز. بيقدر اي واحد برضه يفوت على الويب سايت تبع الاي سي اي ويسجل وياخذ شهاده متخصصه باي وحده من هذه المواضيع الاربعه وبكون سيرتيفايد فيهم. حكينا عن الاونلاين برزنتيشن. هاي بعض الدوكيومنتس الخاصه اللي بنسميها education documents، فيها معلومات مهمه جدا لاي شخص بكون مهتم يعني يعطي محاضره، ممكن دكتور في الجامعه بيقدر يعتمد اعتماد كلي على هاي الدوكيومنتس بانها فعلا تعطي الفكره المناسبه للطلاب. في موضوع اخر مهم بالاي سي اي كمان يعني حاب شويه صغيره اركز عليه اللي هو الاي سي اي سيرتيفيكيشن. الاي سي اي سيرتيفيكيشن بتهدف انها تاهل العاملين في قطاع الخرسانه سواء مهندسين او فنيين بموضوع معين بالفحوصات الخاصه بالخرسانه. وتعتبر معهد الخرسانه الامريكي يعني من اكبر المؤسسات اللي بتمنح الشهادات المتخصصه في هذا المجال. على سبيل المثال يتم عقد، طبعا هذه البرزنتيشن شوي قديمه لكن بسنه 2018 كان في اكثر من 40,000 اكزام تم اصداره على مستوى العالم. هذه بعض المواضيع اللي الاي سي اي سيرتيفيكيشن بتهتم فيها. طبعا في معظم الولايات المتحده الامريكيه الاي سي اي سيرتيفيكيشن للبيرسونيل هي متطلب اجباري. والجدير بالذكر هون انه برضه في بعض الدول بالشرق الاوسط بالتعاون مع الاي سي اي تم اعتماد هذه السيرتيفيكيشنز كمتطلب اجباري عندهم، وتم اصدار الشهادات بالتعاون مع هذه المؤسسات والدول، طبعا مؤسسات رسميه في هذه الدول، بحيث تكون سوبرفايزد من هذه المؤسسه الحكوميه. هذه بعض المواضيع بالسيرتيفيكيشن. وين ممكن انه تلاقي الاي سي اي سيرتيفيكيشن سبونسرنج جروب متوزعين بمعظم دول العالم، وزي ما انتم شايفين بالشرق الاوسط في عندنا سبونسر جروب بيقدموا هذه الخدمه. انا بدي امشي سريع عشان اترك المجال برضه للدكتور خالد. اهم السيمينارز او الكونفنشنز او الايفنتس اللي بتكون مع الاي سي اي. الاي سي اي عندها 2 ايفنتس افري يير، واحد بالشتاء بالفول وواحد بالربيع. طبعا احنا صرنا ميكس عربي وانجليزي فبدكم تتابعوا معنا. النكست اي سي اي كونفنشن راح يكون باكتوبر 20 بمدينه سنسناتي ولايه اوهايو، وبتمنى يعني الحضور من الجانب الاخوان بالمملكه العربيه السعوديه. تقديم بسيط عن الاي سي اي بالشرق الاوسط. في يعني حوالي 11 تشابتر موجودين بالشرق الاوسط للاي سي اي. في اكثر من 44 انترناشونال بارتنرز للاي سي اي بالعالم، 5 منهم موجودين بالشرق الاوسط. اهم الايفنتس والسيمينارز اللي موجوده معنا خلال 2019 كانت يعني شهر 6 كان في حوالي 4 محاضرات موجوده وبرزنتيشنز وسيمينارز بالامارات العربيه المتحده. احنا الان موجودين بالمملكه العربيه السعوديه استضافه كود البناء السعودي. راح نكون في مصر كمان، وراح يكون في برضه مؤتمر خاص بالاي سي اي لمده يومين بالمملكه الاردنيه الهاشميه بعمان بشهر 11. فالكل مدعو انه يكون موجود معنا بهذه الايفنتس. هنا وين توزيع الاي سي اي موجودين. هذه بعض الستاتستكس عن الاي سي اي سيرتيفايد بيرسونيل بالمنطقه. بالختام طبعا انا مره اخرى يعني بشكر الجميع على هذه الاستضافه القيمه، ولابد من الذكر انه التعاون اللي ابداه لجنه كود البناء السعودي مع الاي سي اي خلال الفتره الماضيه هو تعاون راح احكي مميز وبناء، وفعلا احنا تعاملنا مع معظم دول المنطقه، لكن التعاون مع كود البناء السعودي هو تعاون مميز، واتمنى انه يستمر للسنوات القادمه. واي شيء يعني خلال الاي سي اي احنا عندنا الدكتور احمد شريم من الناس اللي داعمين للاي سي اي، وهو عضو بارز معنا في عده لجان في الاي سي اي. فكل الشكر لكم جميعا، والسلام عليكم ورحمه الله وبركاته.
نشكر الأستاذ أحمد مهنا على هذا التعريف. والآن يسعدنا أن نستضيف هذا اليوم الدكتور خالد نحلاوي ليحدثنا عن أول كود أمريكي أصدر خصيصاً لإصلاح منشآت الخرسانة المسلحة. والمهندس خالد حاصل على درجة الدكتوراه ورخصة مزاولة المهنة الاحترافية، وهو أيضاً كبير مهندسين متميز في معهد الخرسانة الأمريكي، ولديه خبرة طويلة في هذا المجال تجاوزت 20 عاماً. فليتفضل.
بسم الله الرحمن الرحيم. السلام عليكم. أتقدم أنا باسمي وباسم ال ACI. أشكر أمين العام للجنة الوطنية لكود البناء الأستاذ المهندس سعد شعيل، ومستشار المحافظ الدكتور أحمد الشريم لاستضافتنا في هذه المحاضرة. سأكمل محاضرتي باللغة الإنجليزية. هذا تقصير مني لعدم معرفتي بالمصطلحات الإنجليزية باللغة العربية، فأرجو المعذرة. I started with the ACI back in 2009, but before my first time, fresh out of school, my first job was in California. So nothing in the world except my possessions in my car. I drove all the way from Michigan to California. And my welcoming was the Loma Prieta earthquake, 1989, October 17th. That was the first day in California. Driving down Silicon Valley, the earthquake hit. I didn't know what was happening. So it was a strange welcoming. Next day, I went to the company. I told them, you don't need to get me work. I came and brought work with me. And sure enough, a week later, the president of the company came and asked me, do you want to work in repair? I told him, I have no experience. He said, nor do I. So for the next 5 years, all I did was strengthening and working on design of and reinforcing of concrete and masonry structures. Then the 1994 Northridge earthquake occurred in Los Angeles, and I was sent there for 6 months, and I also did only repair of concrete structures and steel structures. After 5 years doing hard work of repair, my wife told me enough is enough. I was too much out of home, so I went back to Michigan and did for the next close to 15 years consulting and doing work for heavy industrial work, automotive and other industrial work. In 2009, I was involved with organizations such as the local ACI chapter and the Structural Engineers of Michigan. Somebody mentioned there is an opening at ACI. So I thought, what does ACI do? So I submitted my resume, and next thing I got a phone call for an interview. I went there and I asked them, what do you do here at ACI? And they told me we're reorganizing the code, the 318. And being as an engineer, you all know what 318 is. I said, well, it's an opportunity for me really to learn what the code really is, how things are being done. So I submitted my resignation and joined ACI. And it has been really a very fruitful and very good experience. So with that, I will get into my presentation, the 562. It is, I think that it is the first code in the world that talks about repair, rehab of existing concrete structures. Or it could be one of the, I should not say the first because I don't know, but I think it's one of the first, if not the first. And so the overall objective of this presentation is to introduce you to the 562 code, how it works, what does it involve. And we talk, for example, what code would you use when you're doing your repair? Would you go to the original building code, or would you use the current building code? And understand also the load combinations. Are they the same as the current code, or are they different load combinations? What test methods and what strengthening methods are acceptable in this code? So, but before talking about the code, let me give you a little bit of a repair history. Concrete structures have been around for a very long time, and actually for hundreds of years. So it is a reliable material. It's moldable, it's dependable, it's fire and weather resistant. So we have a good material that has proven itself over centuries that it does work. So why does it fail? So if I ask you, how big is the repair industry? Before coming here, I tried to find out how big the repair industry is here in the Kingdom of Saudi Arabia. I searched for quite a bit. I couldn't find. Actually, I couldn't find a number for the whole region. But the amount in the US, it's about close to $21 billion a year. And those numbers are from the 1912. Currently, the number is about, I've heard, it's about $30 billion a year. So it varies. So how, I mean, the repair really evolved over many years. Back in the 80s, 2 studies were published, 2 independent studies, one in the US and one in UK, where people wanted to find out if we have repair work, how long does that repair work last? So, and here I'm showing one study that was done in the UK. And we're looking at about 215 case studies. And if you add all those studies, they add to more than 215, because a structure could have more than one failure or more than one deterioration issue. So a structure would have been documented under more than one. Could be corrosion, could be freeze-thaw, could be deteriorated concrete, or poor construction. So here are the structures. Then those structures were repaired using the state-of-the-art at the time of the repair, using conventional methods. And again, a repair could be done under more than one method. Could be patching, could be crack injection. So again, it was documented under more than one of those categories. And then after that was done, they observed and they checked how long does that repair last. So what they found out that within 5 years, about 20% of the repair work failed. Within 10 years, about 70% of the repair work failed. So that's really substantial. Imagine yourself being an owner, and you hired somebody to do your repair work, and within a few years that failed. You as an owner will not be happy, right? You'll be very upset about it. So then this group came together and said, why did this repair really fail prematurely? So they categorized the failures into two categories: engineering issues, one of them being under the engineering issues that the engineer incorrectly diagnosed the cause of deterioration. The engineer was not well educated, was not well prepared, and so it is not really fair to the young engineer or for a company to send a young engineer to a job site to do repair work, because he does not have the experience, does not have the expanded knowledge or the know-how to do repair. A young engineer fresh out of school has been taught, has been educated on how to do new design. But repair work has never been taught in school. I was never taught how to do repair work in school. I learned that on the job site, and I learned it the hard way, right? I learned when I was thrown out on the job site and told, look at your how to repair structures. So it requires a little bit of education, a little bit of knowledge. So another type of repair, also one of the other issues was that the engineer may have diagnosed correctly why this structure really is deteriorating or failed, but the repair work was not done properly, or specifying inappropriate material. There's a lot of material out there in the industry, and material suppliers want to sell you their products. Believe me, there's nothing wrong with the material that they may have, but each material has a specific application. So it's good for the engineer to talk to the material supplier to find out what type of material is really appropriate for their project. The other category that they put together was the construction issues. Many times the repair is so involved, it's not straightforward. So the design itself is not your common design work, so it's a non-standard. Sometimes the engineer, the contractor, would take shortcuts or would say, I don't want to follow the contract documents, I want to do it differently. And I've seen that. One time I was on a job site, and there was this young superintendent. I had prepared the drawings. I went out there just to inspect, and he came to me really happy and proud of himself. He says, I know a lot. I don't really need those drawings to follow. I know how to build it. I don't need to follow those drawings. So I went back to his boss and told him, you better watch over your guy over there in the field. As an owner, it's hard for you to see your project or your building not working. It's under construction because you're losing revenue. So you want your project to be, the construction to be done like yesterday. So the contractor is being pushed to accelerate the work. Repair application and workmanship issues. It is also important for the common worker to be trained and to be aware how to apply that repair work. And we talked about the material differences. So from this, what we've talked, the industry felt that there is really a need for a repair code. And actually, what was mentioned earlier, that ACI is of its members. ACI is it's about the members. So the members came together and they said, we would like to have a repair code. And it came mainly from the people who are doing the repair, because they've seen a lot of issues in the field, or that comes out of engineering offices that were not correct. And ACI just obliges. ACI headquarters does not impose anything on its members. It's actually the other way around. The members would ask, we need to do this or that. So When this committee came together, one of the options was to put a document together that addresses the overall repair issues and that is flexible, as I mentioned, to address the overall repair issues. And most of you are aware of 318. 318 is mainly a prescriptive approach. It tells you exactly what needs to be done. For example, if you want to calculate the development length, there is an equation. If you want to calculate shear, there is an equation. So it tells you exactly what needs to be done. But when it comes to repair, it's hard to put it in a prescriptive language. So the code is mainly performance. It tells you it shall be considered. The engineer has to look at this. So, and it has some also what we call some prescriptive language, but mainly it's performance-based. So the code is addressed to the engineer. It's not to the contractor, it's to Mr. or Miss Engineer. They are responsible for it. The engineer is responsible for the overall repair approach, from assessing a structure to specifying the material, preparing the details, putting together a quality control, quality assurance program, to discussing with the owner how to put together a maintenance program for the longevity of the repair work. Also, in the US, when it came to the building inspectors, many times building inspectors would tell the engineer, I mean, there was no document to go back to or to reference to tell the contractor or to tell the building inspector that the engineer followed a certain rules or certain requirements to put the repair work together. And many times the inspector or the building inspector would enforce the current code on any repair of existing structures, which resulted in very expensive repairs. And many times the owner would say, why should I repair if it's going to be that expensive? So it would go and demolish the structure. And owners also, on the other hand, would be aware of what they're buying into. What are they getting? What's the worth that they're getting from that project or from that engineer? So the code, in general, applies to the assessment, repair, and rehab of existing concrete structures. In the US, we have different code levels. There is what we call the IBC, which you're familiar with, which has been adopted here. So within the IBC, there is also a code called the IEBC, or the International Existing Building Code, which is less known, because it's also not universally adopted in the US. And this code, the IEBC, does not address material. It's overall for analysis. And it's only adopted by about close to 80% of the states or jurisdictions within the US. So 562, if the IEBC is adopted, could supplement the IEBC, because the IEBC does not address material. And if not, like states that have not adopted or jurisdictions that have not adopted the IEBC, then the 562 could be used as a standalone code. For example, we have the state of Ohio, which is south of Michigan, has not adopted the code, the IEBC, but they have adopted the 562. So the 562 can be used as a standalone code. By the way, I'm talking here, maybe you saw in the program, there is about 45 minutes towards the end for questions and answers. I prefer if we have questions and answers as I talk, so I can address them, because if we leave it till the end, you may forget or you may lose. So just raise your hand and let me know, and I'll stop and I address it. If it's going to take too long, I will ask you please to defer till the end of the presentation. Okay? So, and also if the jurisdiction or the community anywhere has not adopted the code or does not have a repair code, the engineer could use this code as a map to repair the structure, and then can go to the jurisdiction or to the inspector, to the building authorities, telling them, you know, I followed this document. It's a consensus document. So here are the chapters within the code. We have about 10 chapters. You see here, for example, Chapter 4. Chapter 4 is used if the IEBC has been adopted by the authorities. Appendix A, if it is a standalone code. So the code is divided also into 4 categories. The first few chapters, we call them the prelim evaluation, where I'm doing the prelim evaluation. Chapters 5 and 6 are for structural assessment. 7 and 8 for design. 9 and 10 are for construction. And I will briefly, because of the limited time, I will go very quickly and highlight what's in every chapter. This seminar, we give it in the US for over a full day seminar. So here I'm trying to compress the information as much as possible, and I hope that I will be able to deliver the message. The intent of any code, any standard, irrespective, is to safeguard the public. It's for the safety and health of the public. That's the first priority of any standard. The user is the engineer. Or in this code, the engineer is mentioned as the licensed design professional. I may be using quite a bit of terminology. What ACI has done, they have created what we call sort of like a terminology explaining what each word means, like a dictionary, but a concrete dictionary. So that's here the website, the address where it's downloadable for free from the ACI website. The code is applicable to any concrete structure, any building. So it's for foundation, composite members, precast, post tensions. And you see the slab on ground, I have it as a question mark. The slab on grounds are usually, because they are non-safety issues, okay? They're not considered part of the repair, or the code does not address it. Unless the slab on ground is connected to the structure and transfers, let's say, lateral loading, like part of the lateral system. In that case, or it's a structural slab as a self-supported if you have weak soil, then it will be addressed. But if it's your normal slab on ground slab, then the code does not really address it. It's also for non-building structures, but has to be concrete, like bridges, tanks, silos, or any concrete structure this code would apply to. It's not applicable to non-structural concrete, or if it is aesthetic improvements, unless if you're doing any aesthetic improvements, it may fail, and if it fails, it may hurt somebody. In that case, then the code would apply. Now, if we look at seismic, the code 562 does not address seismic issues for repair. In this case, the code will refer you back to ASCE or SAI 41. I assume everybody here is familiar with ASCE documents? Okay, so I see some nodding, so I'm not going to go into it. But ASCE 41, also it's a general document, it's a standard, it's adopted in the IEBC, but in general does not talk about concrete. ACI 369, which is also another committee within ACI, did come up with a standard for repair of concrete structures in seismic zones. So ASCE 41 references this document. So ACI is referenced in ASCE 41 through 369. ACI does not want to stifle any advances when it comes to new innovations, when it comes to construction, design, or analysis. So it allows the engineer to come with new ideas, new methods of design and analysis. But it has to be submitted to the authorities. The authorities have to approve it, okay? Otherwise, it's not going to work. So they can show it either by successful use, that it has been used for many, many years successfully, or by analysis, or going through a testing program. Actually, when I was in the US, Actually, I'm still in the US, sorry. When I was in California after the Loma Prieta earthquake, we had a very beautiful structure that was built in the 1850s, was built by the community. Very old and had very nice painted ceilings inside. That ceiling was insured for over $1 million. So it was really badly damaged after the earthquake. It was in Santa Cruz. So the owner wanted to repair that structure. So they invited other engineering firms. They came up with steel framing or concrete framing, which really damaged the appearance of that structure from the inside and outside. At that time, I was working for a European company. They had some methods of strengthening structures because they have their old structures, the castles or the fortresses. They're using post-tensioning for strengthening unreinforced masonry. So we came up with that idea to use that same method for that, repairing that structure. Well, the building official told us, well, we don't have the experience. It has never been done in the US. We told him, well, it was done in Europe. It has been done somewhere else. He said, show it to me. So we went through a rigorous analysis. We went through inelastic analysis, computer, and so forth. He did not have the experience, so he hired an outside agency, consultant out of San Francisco, to oversee our work. We went back and forth. It took us about a year to approve it. But eventually it was approved, and we were able to build it and construct it. So, as I mentioned, the code does not want to stifle advancements or ingenuity or new methods and analysis. So, the first thing when an engineer is called out to the job site has to ensure that the structure that has deteriorated or is damaged is safe. That is the first thing that they need to do, is to ensure that the structure is safe, that does not, that may not result in damage or may hurt or injury to people. And that it is in compliance with the original building code. Was it designed properly? Did the engineer follow all the requirements of the code at the time of constructing the structure? So prelim assessment is divided here into 3 categories: review of existing documents, visual inspection, and doing prelim analysis. Review of existing documents, or a review of existing information. The first thing the engineer needs to do is to collect all the information that is relevant to that structure. And you start with knowing to what code was this structure built, okay? What was used? I mean, here in this case, here, like in the Kingdom of Saudi Arabia, did they use the British code, or did they use the Euro code, or did they use the ACI 318 XYZ version from whatever? So you need first to identify what was the original code. Try to find out the original also construction documents. Are they still in existence? For example, in the US, the first thing to go to would be the building official, to go to the building department and find out if they have the construction documents. Many times for very old structures like built in the 20s or 30s, that may be very hard to find. And if the calculations are available, that would be even better, that you have those calculations and you can find out if the engineer did follow the calculations properly. So first of all, try to gather all that information. Another thing is that also try to collect the material information that was put into this structure. If you may have the concrete mixture components and proportions. Is that available to you? The mill test report for the reinforcement bars. What protection systems were used? And any material that was put into the structure. If you're able to get that information, that will help you in your assessment. Construction information. Do you have the RFIs, request for information, or any change orders that came about? I was working one time on a project where we had over 200 RFIs. Okay, so those would be kept within the company as a reference for future. Any quality control data or inspection reports. Photos are very important. Nowadays, people have those iPhones. You know, they take them and they take pictures. If you have those, keep them for your records. Those are very important. There was a project in New York where there were cracks. So the engineer went and looked at the drawings, calculations, everything looked fine. But there were cracks, and the cracks really did not match what's on the drawings or the calculations. So it was puzzling. And the contractor said, well, I took few pictures. I have pictures. So the engineer jumped at him, told him, let me see the pictures. So he took a look at the pictures, and the contractor, when they were doing the awnings when they're doing the awnings, they added some steel plates to aid them in the construction. But they did not remove them. And the cracks really occurred at those steel plates where they added them. So sometimes photos would help in determining why a structure had failed or cracked. Soil bearings, also another information that would be helpful in your design if there are some settlements. Service history. During the lifespan of the structure, was the structure properly maintained? Is there a manager? You can interview that manager. If there was a leakage, when did the leakage was first observed? Where did it come from? So that would be also important to have if you have the service history. Personal experience is valuable or it's invaluable, right? Because you as an engineer, you're familiar with the region, you're familiar with the area, with the environment. You know how a structure would behave in such an environment. So your experience is really invaluable to bring into this project. And if you are an experienced engineer, you've been around for quite some time, you know, for example, 20 years ago, the concrete strength was such and such, and the construction methods were such and such. So you can relate how things were put together, how things were built together. That all will be part of your personal experience. Historical structure. As I mentioned earlier, many times we don't have any information on the structures. We don't have any drawings, we don't have any information, nor photos. In the US, we have what we call historical societies, where they try to gather that information. I'm not sure if such things occur, do you have it here, but if there's one in existence, it will be also very interesting or very important to go to those authorities and find out about those historical structures if there is any information that may help you in the repair if it's needed. So now the engineer sitting in the office gathered all that information, got all the drawings, the reports, the calculations, if they're available, studied them. Now the next step is to go out and do as is. Go out to the job site and see what's on the drawings. Is it really what's out there in the field? Do they match? Were there any changes that have occurred over the years that were not documented? Okay. For example, member sizes. Do they match what's on the drawings? For example, the beams or the columns were 400 by 400. What's out there in the field? Do they match? Are they 450 by 500 or are they 450 by 350? So do they match? We have also those tolerances, right? When we do construction, there are tolerances. Can observe if there are any material deterioration. The engineer, when they design, when the structure is built, you assume everything is to the norms. I shouldn't say perfect because there's nothing perfect, but everything is done as planned. But now, because of deterioration material, has the material deteriorated? Any signs of distress, like cracks, unusual cracks? That's from structural point of view, but there's also issues about serviceability. If you have excessive deflections, why do we have excessive deflections? Is it because of overload or under design? Do we have water leakage? Vibration. Sometimes a structure is fine. I mean, it doesn't show any distress, or there are no cracks or any deterioration, but there is a vibration, which is what you call it, gives the occupants a feel of uneasiness. My understanding, when the first high-rise buildings were built, there was no information about what was limiting the lateral deflection. Many people who were living in the high-rise at the top floors would get seasick because of the movement of the structure. So that's also an issue that needs to be looked at. After going out to the job site, after doing the gathering all the information and doing the visual inspection, and checking actually what's out there in the field, the engineer may take several steps, either doing nothing because it's just minor, or if it's excessive, may require to shore the structure and prevent access to the building. I've been involved with a few projects where the owner asked me to come out and take a look where there was leakage from the roof. And it was a plant, automotive plant, and they had concrete tiles as roof. It was an old structure. So you saw cracks and you saw what leakage. It was wintertime. So I went there and told him, what's up there? What's sitting up there? He said, nothing. It's just empty roof. And there was snow. But when I went up there, it was low roof and high roof. So what happens is that you have all that snow, because of snow drift, it piles up. So you had about 2 to 2.5 meters of snow sitting on top of that roof. That's all weight. So the concrete tiles cracked under the load, and I told him it needs to be quarantined. You cannot have people moving or walking underneath that roof. It has to be quarantined. So you as an engineer need to take the steps, make sure that you do not jeopardize the safety of the public using that structure. So I'm going to step a little bit aside and talk about cracking. Why do concrete members crack? There are several issues. For example, material deterioration, steel corrosion. Maybe you have quite a bit of steel corrosion here on the east and west coast, but I've heard today or learned today that you also have it here in Riyadh. So steel corrosion is the #1 issue when it comes to concrete repair. We talked about construction workmanship, design deficiencies, or overloading. So when we talk about cracking, it's really a very big topic. You may take about a full day just talk about it. So I will only go very quickly, address a few points just to bring the message across. I'll be talking about the drying shrinkage, volume change, ASR, and sulfate attack. So in general, why does concrete crack? It's mainly because if you have fresh concrete, because of the loss of moisture, okay? So you lose moisture much faster at the top than in the inside, especially when you have a climate or environment like here. You have very hot climate, concrete is still fresh, you still have water down below, but at the top, it dries. When it dries, what happens? It tries to shrink, right? Whereas internally, it still hasn't shrunk yet. So what happens? You get those fine cracks at the top, where the tensile strength or stresses in your concrete exceed its capacity, as we see here. So you get loss of moisture, and you get the cracking. I ask, for example, the question, when I'm in the US, we say from the East Coast to the West Coast. So if I ask you here from the East to the West Coast, it's about 1,500 kilometers. If you build a highway, concrete highway, with no joints, just one continuous concrete placement, and assume that there's no friction, okay? Just one concrete slab, no friction, and you allow it to shrink, how much do you think it will shrink? Any takers? Just throw a number. 50 meters, 100 meters? It will shrink approximately about 600 to 700 meters. So if you build a highway from Dammam to Jeddah, assume 1,500 kilometers. Excuse me? It depends. So it depends, like 0,004 or 5, whatever. So it's about close to 1,000 or 700 to 1,000 meters. So, but the point is that if you build that highway, you will not reach your destination. It will be short of your destination. So that's what we have here with the shrinkage. So concrete needs to breathe. So that's why you provide joints. So you have them intermediate joints, so to allow the concrete to crack at certain locations. We talk about volume change. We have heat of hydration and changes in ambient temperature. When we talk about heat hydration, it's mainly mass concrete. And you see those because, again, the inside of the concrete is still hot, the temperature is hot, whereas the outside, which is in contact with the environment, cools down, so the concrete cracks. And there are some requirements. There are ACI documents that talk about the requirements of limiting the high temperature and the difference between the external and internal temperature in concrete. And there are other methods how to mitigate those cracks, as talked here, with the thermal gradient. Also, we talk about ambient temperature. If you look at the picture here on the left, that was built with no joints. Here you have that one slab that continues for over about 150 meters long with no joint. And they built then this curb on top of it, which acts as a restrainer. Many years later, if you see now that structure, here we don't have a structure, here we have a structure that was built many years later. But what we see here in the curb, that we have a crack, because again, the concrete wants to move. And it finds a way where it would crack. Just quickly over alkali aggregate reaction. Here's a picture of two concrete placements. One with proper aggregate, and another one where we have poor aggregate that has alkali silica reaction. So you see the cracks are random, what you call, it's like an alligator pattern. Maybe here, alligators are only in the US, maybe we call them the crocodile patterns. And the way you find out that you have this ASR is that gel deposits around the cracks, or what we call the efflorescence-like gel. And the way that occurs is when you have alkalis, they react with the silica, okay? They create around the aggregate what we call the alkali silica gel. If there is moisture or water within the mix or that comes from the outside, that gel expands. When it expands, it takes volume. And that volume needs space. So it pushes against the concrete and you get those cracks. So here's a petrographic picture of concrete. And you see here that wide deposits, or that oozing of that material goes out to the top of the concrete. Sulfate attack. There was a study that was done in California, Sacramento, where they took concrete samples. They designed them with different concrete types, from type 1 all the way to type 5, and also with different water cementitious ratio. And they placed them in a bed that is saturated with sulfate, and they left them for about 6 to 7 years and observed how the concrete would behave. And here, if you look at those were done with type 1 cement with water cement ratio with greater than 0.5. Nothing else, just left them in that bed. Because we know that sulfate really attacks the paste, the concrete paste, right? It attacks it. And whereas here, we have type 5 cement with less than 0.5 water cement ratio. So the water cement ratio plays a role. The type of cement also affects the behavior of concrete. Here, where we have two sets of specimens, both of them with type 5 cement, but different water-cement ratio. And you notice that the one with the higher cement ratio has more deterioration than the one with the lower water-cement ratio. Corrosion, as mentioned, corrosion is the #1 cause of failure of concrete. I got that number from NACE. I don't know if that is true, but that talks about steel in general. I don't think it's just about construction or buildings. It says that the cost to the kingdom due to corrosion is about $19.3 billion. It's a huge number. It's a very big number. So, and that does not include the loss in revenue. In that case, the cost will jump quite significantly. And that number comes from, as I said, here I have the NACE report, 2015. So, why does steel corrode? There are different factors that affect its failure. For example, first of all, the concrete quality. Do we have concrete quality, good quality? The water cementitious ratio. Do we have chloride in the mix? I'm sure that nobody here would allow any chloride additions like admixtures that have chloride content to be included in the mix design. The concrete cover. Do we have adequate concrete cover? Many times we find that concrete cover is not there. Temperature, chloride sulfate, oxygen. So all those will affect if we get corrosion or not. Here we have a steel, right? A steel bar. When we place concrete, okay, concrete has a high pH number, over 12 or 13. So what does that do? It will create a film around the steel, a passivation that will protect the steel. So over the years, okay, it will protect the steel. Okay, but we know that from the environment, we get carbonation, we get chloride, and what may happen from the outside carbonation, it may penetrate into the concrete, will reduce the pH in the concrete, right, until it attacks that layer. It will take out that layer, and steel would corrode. If I ask you, for example, how fast does carbonation penetrate the concrete? It's about 1 millimeter per year. So if you have 25 millimeter cover, you'd assume about 25 years, give or take, if you have no cracks, right? If you have good concrete cover, good concrete, it may take 25 years for that carbonation to reach the concrete, to reach the steel bar. The same thing with chloride. Chloride enters the concrete, will attack that film, and the steel bar will corrode. Here's a picture where you have, that was taken from Virginia DOT, where they had here a bridge, and there was a crack. I don't know if it was a crack intentionally put there or not, but those bars were epoxy coated. And if you notice that, although with the epoxy, because of that crack, there is leakage. In the US, we have, especially in that region, snow. They put ice, or they put salt. They spray salt over the roads. So it's chloride. It came down, and you have corrosion here in the bars. And that bar is ruptured. I don't know if it's because of the corrosion or for something else. Now, how would you recognize, for example, cracks or deterioration due to corrosion? If your cracks are closely placed together, you get the cracking, and those will be telescoping to the top of your concrete member. And those will be separate cracks. If the cracks are away from the surface and widely spaced, you'll get that spalling or pop-out at each location of your bar. And if they're deep, if they're away from the surface and they're close together, that's when you get your delamination. Construction defects, sometimes you have during construction, you get those issues. For example, the contractor would, in order to expedite the work, make his life easier, would add water to the mix design to make it more workable. But it will change the concrete mix design and may result in untimely failure. Does not follow the curing protocol or regime strictly. That also may affect the outcome of the structure. Poor execution. Here, for example, those are pictures. Those, I did receive them at the headquarters from a contractor. He told me, or the engineer, he said, we removed the forms, and that's what we found. What should we do? It's a tough issue, right? What should we do? What should be done? Or when you build, you have the tolerances are not properly done. It's not properly erect. So those are issues that need to be addressed right up front. So that ended up to be quite a bit costly for the contractor to repair. Sometimes you have design defects. Most of the failures that we see are mainly due to shear. Has anybody seen here a failure due to flexure? Like a beam failing in flexure? I mean, through my experience, I haven't seen any. Because flexure is usually properly designed, but shear, it's still that unknown. Most of the failures that occur are actually based on like punching shear. Last year, there was a failure in Florida. Maybe you've heard of it during construction at the University of Florida. They were putting a new bridge, still under construction. They were stressing it when it failed over the road. Unfortunately, few people got more than injured, passed away. So what they found out is while stressing, the engineer, they think it's still under litigation. But so far, everything is hinting towards that there was poor design. Again, here, when it comes to design, what you see here, there is here that an expansion joint. The engineer did not provide any bearings, right? Sitting on that column, and you see that crack here in. The structure wants to move, right? It wants to move, but that column is preventing it. So it needs to go somewhere. What happened is that column cracked right here in the middle in that parking structure. So those are some of the design effects. Again, excessive deflection. The engineer did not take into consideration the maximum load, or it was under-designed. Here's again excessive load, and sometimes overload is beyond the engineer's, did not know about it. Like here we have in Katrina, there was flooding, overload from water. It washed it away. Or here, in this case, the owner added a very heavy load such that that beam failed. There are quite a few documents within ACI that talk about the repair or talks about the deterioration. For example, here, the causes of cracks. We have your guide to durable concrete and report of thermal and volume change. Here, this document is just addressing cracks. It's a very good document that talks about the issues in concrete, why concrete cracks, and how to mitigate those cracks. One thing that I want to alert you here, maybe you're aware of it, but just for those in case somebody is not, when you see a document that is followed, the number is followed by letter R, that means it's a report or guide. It's not a standard, it's not specification, it's a report. So it's based on best practices that the committee came up with. The committee thought that that's what needs, or based on their experience, they put it all together. Durability of concrete, that's also a guide. But one thing here I want to mention that as of last convention, this committee is now undertaking a project of writing a standard for durability of concrete. So within maybe hopefully 5-6 years, we may have a standard when it comes to durability of concrete. Preliminary analysis. So as mentioned earlier, that when we do our prelim analysis, we are allowed to use either the original building code, if we know to what code the building was built to or designed to. We can use the current building code. You have to check with your jurisdiction, your building department, what code are you using? For example, what code are you using here for 14 or 318.14? Yeah, okay. So it's the 14 version. So you can use this version. Or you can go to Appendix A. And I will quickly and briefly touch bases on this Appendix A without going into too depth because that takes some time. Between the current and original? Well, it could be that the code was built, I mean, the structure was built to 1971. So it's a different version. So in 14 now has more information, has maybe different equations, okay? Right, it's being updated. So what I'm saying is that when you check your structure based on the original building code, you don't take this updated information into consideration. Because the structure, when the engineer built it based on, let's say, 1971 code, did not have that information at that time. So you only design it for that, or you check it for that information. So also when you look at the material, what type of material would you use? You can use the listed material if you have those available from the documents, or you may go to historical data, which I will talk about later in Chapter 6. But it's advisable when you check the member sizes, take the actual member sizes. Don't go to the drawings and say, well, the drawings show that the column is 400 by 400. No, you go and measure and you use the actual member sizes or geometry of the structure. What do you do when you find out that, or the prelim analysis reveals that the structure is unsafe? You need, as an engineer, it's your obligation, your duty to report it to the contractor and to the owner, okay? Because it's a life safety issue. There's really no leeway or no excuse not to let the owner or contractor know about the deficiencies in the structure and that they may result in life safety or loss of life. If the owner or the contractor don't take any steps to prevent that loss or to prevent anybody from entering the structure, then you as an engineer, it's your duty to go to the authorities and tell them about the issues in that structure. Again, as mentioned, it's the main thing of standards is for life safety, which is very important. Although the engineer may lose the business with the contractor or the owner, but that's really not important compared to loss of life. So the outcome of your preliminary analysis is either the structure is adequate, if maintained properly, you tell the owner, well, it's just minor, just fix that crack, there's nothing really to worry about, and you continue with the structure, just repair it, and observe it over time. Or it's inadequate, and just by reducing the load, if the structure has like design deficiencies, too much weight on a structure, you may tell them, just redistribute the loading, don't put much load on this slab here, and you may, then the structure may, you may continue using the structure. I had that issue, for example, I was called to a social department in the US, in one of the cities, where they saw some cracks in the slab. And when I went there, around the columns, they had all their cabinets around the column. So you had the column, you had 1, 2, 3, 4 cabinets, and fully loaded with paper, and on top of them also stack of paper. So it was very heavy load at that location. So punching shear was initiating. So I told them, just remove the load. Don't put it around the column. Put it somewhere else. Distribute the load. Or it's inadequate and needs remedial work, and it's inadequate and it's beyond repair. at this point, then maybe demolition is the right choice. Or the engineer may say, information is insufficient to come to a definitive conclusion. So additional testing, additional investigative work is required. At the end, the engineer would submit to the owner a report identifying all those issues, putting all the information that he was able to gather in that report, and providing his recommendation. Yes?
When you say it's beyond repair, this will cost a lot of money. So are we going to take the first decision, or we have to go with another opinion, take a decision?
Okay. The question is, when I said the structure is beyond repair, information, here, inadequate and beyond repair. The question is, would you just, is that the final decision, or would you go to a second opinion? Maybe here, when it comes to, as an engineer who's taking that decision has to be experienced, has to have the knowledge, the know-how, and has to have what you call knowledge, experience, and has done quite a bit of repair work. So, yes, you may ask for second opinion, but you as an engineer, it's, as I said, it's your obligation to determine if the structure is safe or not. And if it's not safe, you can take it out. But yes, I mean, you do some investigative work, and I will go into it. I mean, that is just preliminary. The owner may say, no, why don't you do more investigative work? And I will go into that later. I will stop at 10:45, right? That's when we have our first break. 10:45, so that's when I'll take the break. So hopefully we have, okay? Okay. Again, here, probably that will address your question, is that sometimes the visual inspection is not sufficient. Sometimes it's not sufficient to determine whether a structure is deteriorating or corroding. But as I said, it's a good method for initial assessment if the structure is experienced and uses sound judgment. That was the third thing that I want to use. Determine the design basis code. I will go very quickly over this topic here, but just to give you an idea what code to use. As I mentioned, if the IABC is used, then Chapter 4 is not. We use Appendix A. This code talks about current building code. The current building code is the code that is being adopted by the building department. For example, here in Kingdom of Saudi Arabia, it's the 31814. That's what is being adopted here, per my understanding. You have the original building code. Could be the UBC, could be the British standard, could be the Eurocode, could be any standard to which the structure was built in. And we have also the existing building code, which could be the 562 or the IEBC. So what is the design basis code? It is defined, it's the legally adopted code requirements under which the assessment, repairs, and rehab are designed and constructed. Here, we'll look at, in that chapter, we have different categories. For example, we have unsafe structure. What does constitute unsafe structure? We all know the demand capacity ratio. So it tells you if your demand capacity ratio is greater than 1. And what capacity are we talking here about? Okay? We're talking about the existing capacity, not the original capacity when it was designed, right? Because now we are in a new situation with this structure. We have some deterioration, or we're looking at the actual member sizes. So we're looking at the current capacity of the structure. So we're looking at the capacity, which is based on the current building code, the demand based on the current building code, and the capacity based on the original building code. And if that is greater than 1.5, then my repair is based on the current building code. Okay? So then we use the current building code. And as I mentioned, if the structure is unsafe, it has to be reported to the owner and contractor as a first step. If there was no initiation from the owner or contractor to do something about the deficiencies in the structure or to take precautions to prevent public from entering the structure, then the person needs to go to the public authorities. The second one, if we have substantial structural damage. We have here those three equations. I will not go into detail, but the first one, if we look at the lateral force resisting system, and we look at the overall floor, we look at all the vertical elements, columns or walls, in a one floor. And if that equation, here is the capacity based on if there are no deterioration in your elements, as if the structure is new, that would be your original capacity. This here is the current capacity based on current conditions. If that equation here is greater than 0.33, that means we have substantial structural damage, and we use, again, the current building code for repair. The second requirement, if I look at the gravity load resisting capacity system, again, I look at this equation. And what I hear, rather than taking the full floor, I only take about 30% of the area. Okay, I take 30% of the columns or walls of the area in that floor. And I try to satisfy this equation. If it's greater than 0.2, then there is substantial structural damage, then I use the current building code. Excuse me? Yes.
What's the side effect to the buildings? How can we make analysis for these things?
Okay. Flooding is a different issue because it's water. What I'm talking here about damage. Okay. 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 The question is, what do you do if you have flooding in a structure? Okay. What do you do if you have flooding? Flooding is pretty much over all the element, and it is current. You have it right now, so you have to look. I mean, it's hard to quantify what needs to be done. I can talk with you about it later, what we look, but here what we're talking, if there is that deterioration that occurred over a long period of time, or even after, well, I shouldn't say after earthquake, but if you see the damage. I mean, when you come with flooding, do you see, let's say, cracking or something of that sort, or it's just you have the weight, or you have the leakage? Okay, so leakage, it's different, but here we're talking about if there is some deterioration in your element, like you have spalling, you have reduction in your member sizes, if you have corrosion, that your bar has corroded, that you don't have the full diameter or the full capacity of your reinforcement. That's what we're talking here about.
We have some cases in the city here during the heavy rain. There is some problems with the buildings. There's some deterioration of some buildings.
Okay.
So maybe this is about if this is to be taken into consideration some best practices in that.
Okay. Okay. He's talking about soil settlement. That would be addressing it, and that yes, it could be one of those substantial structural damage. Yes, I mean, if you look at it, you look at the capacity, you look at the deflection, so it could be different. Yes, but we'll talk about that. So here in this case, when I mentioned when you look at the gravity load, if it's greater than 20%, then you have substantial structural damage. But at the same time, concurrently with this equation, any element within that area should not have exceed 1.33% for any element within that area. So then we go to current building code. For seismic, as mentioned earlier, we go to ASCE 41. Now, if we have less than substantial structural damage, in this case here, if my demand capacity ratio based on the original code is greater than 1, but less than 1.2 or 1.33, then I can go to the original building code. I don't have to repair my structure to the current building code, which may be expensive or cost prohibitive. Or if it's minor cracking, then I just need to do minor repair. If you look at additions, alterations, change in occupancy, we do that a lot, right? It's been done a lot. An owner wants to add one more floor on top, or wants to make changes, wants to add few bays to the structure, or change a building from an office to a storage, or from residential to an office. So we all know that the live load will change, like the live loading will change. Right, right. So in this case, the code tells you, if you look at the demand, with the addition based on the current code, it's greater than 5% of the demand of the original building code. With that addition, then the structure needs to be upgraded using the current building code. So there are several, I'm not going to go through them, there are several issues that you need to check, either which either would result in going to the current building code or using the original building code. If we change occupancy, if the demand based on the current building code is less than the demand based on the original building code, then there's really nothing to be done. Otherwise, we'd go to the current building code. Now, any new material that you add to your structure, being beam or column, needs to follow which code, do you think? It needs to follow the current building code. So any new material, any new element, any new member that you add to your structure needs to follow the current building code. You as an engineer may elect, well, I'm not going to go through that exercise that I showed earlier. If I want to use the current building code or the original building code, I'm just going to forfeit everything and go to the current building code directly. But as I mentioned earlier, that may be expensive, may cost the owner quite a bit of more money. Let's talk quickly about the load factors, and then we'll take the break. Okay, that will take probably 10 minutes. One thing is that you don't want to mix and match between load factors and reduction factors and load factors, because those load factors and reduction factors are calibrated based on statistical analysis to get a certain safety factor. So if you are working the structure, checking it, looking at the original building code and the current building code. So don't take, for example, the load factors from the original building code and the reduction factors from the current building code, because then you have an issue. I've been asked, before coming here, I was in a neighboring country, and an engineer came and said, well, we use the British code and the ACI, so I use the load factors from the British code and the reduction factors from ACI. And I said, you cannot do that. Those are two different things, because he has lower reduction factors when it came to the, let's say, the British code, and he has also lower reduction factors from the ACI. So he's taking the easiest out of both worlds to come with a lower load demand on the structure. That should not be the case. So you don't mix and match. When you're doing your repair, the loads on the structure, you use the ASCE 7. If the building is occupied, if it's not occupied, you can use ASCE 37. 37 provides lower loads on the structure because it's unoccupied, you have only construction, and it is only for a limited time, right? When we use the load factor, the loads from the current code, it's for the longevity or for the lifespan of the structure. But construction is only for a few months, so the probability of having a very high load is very low. And seismic, it's 41. Again, when we're looking at demand capacity ratio, we need to maintain this, satisfy this equation or this inequality. We have two reduction factors in the code, okay? Here in that 562. We have this reduction factor, which is based on no testing, no providing any evaluation. Or if I'm doing testing, if I've tested the material, I know my cross-section, my member sizes, then the code, because now I have a higher reliability, I'm actually working with the actual member sizes. I'm working with the actual material properties. The code increases those reduction factors because of a higher reliability. The code allows for external strengthening, being post-tensioning or FRP. So the code here now allows FRP for external strengthening. If we look at the post-tensioning here, we have what we call it direct attachment to the concrete. So we have positive attachment. But when you look at the FRP, it's based on epoxy. So there are issues with non-mechanical strengthening systems. And so the code has two requirements that needs to be satisfied in order to use the non-mechanical strengthening system. One of them is this first equation, the S stands for snow. You don't have here snow, so we have to take this equation out. But we look at the other equation. So without strengthening, so without the FRP, the structure has to maintain this load, the 1.1 dead load plus 3/4 the live load. If it satisfies this without the FRP, because if you have the FRP, you may lose it due to vandalism or whatever reason, you will need to make sure that the structure can still maintain a sufficient load to alert the owner or the occupants that there is something wrong and they can do some emergency issues. The other thing is fire. If you have fire, again, we have the 1.2 dead plus 0.5 L. We have even lower reduction. And the reduction factor is 1 because the probability of having fire and full live load is even smaller. So even without the FRP or with any that non-mechanical system, it has to satisfy this requirement. So let's take a look. If I have this member, if I apply fire to it, here's that graph. Here I have temperature, increased temperature over time. Here it's per ASTM. That's the load regime in ASTM. As you see, within a few minutes, you get very high temperatures, and then it tapers off till about 1100. Here, let's take a concrete beam under fire. Concrete is a very good system to protect the reinforcement inside the member. But this temperature propagates with time into the member, right? So if we leave it for a very long time, eventually that whole member will become red. So here, that's the temperature in the reinforcement. As I mentioned, it's protected, so there is a lag in temperature increase in the reinforcement. So here we have, like in 20 minutes, we have, let's say, 800 degrees, whereas here in the bar, it's still below 100. So it lags behind it. Now, what about the capacity of my member? It decreases also with time. So that's the member capacity. It decreases with time. So codes tells you about 2 hours. That's what you need to protect your structure for, about 2 hours. So if you look at it, it's about 55% of your capacity. There's a standard in ACI called 216. It's a standard or specifications where for fire, you can go to 216. Here we have the bars. If you look at reinforcing bars, up to 300, bars work fine. Beyond that, the deterioration is very quickly. For pre-stressing, it's only up to 100 because you have positive tension. Temperature will relax the bar, those strands, so you lose your stressing forces. As you see here, concrete, up 500 to 600 degrees, it works fine. Beyond that, there is also deterioration. So let's take here also, just quickly take a look at this member. When we design, your demand is this graph here, which is 1.2 dead plus 1.6 live. And your capacity is per the code, as shown here. If we have fire, we said that the capacity decreases. It reaches here. And what we mentioned earlier, that in order to use the FRP, you need to maintain a demand such that when you lose your FRP, that the structure can maintain this load. Right, it's the same. Right, correct, yes, it's all the same. Okay, so any questions to this point? Okay, I think then we'll take a break. Okay.
I would have a question because I shared the most with regards to slides 49.
49. Okay, let me see if I can get to that. Bismillah.
flooding. Yeah. It's a big problem.
Yeah.
It is a big problem.
Yeah.
So if there is this practices, how to protect construction to
البروتكشن تبع الفلودنج اول شيء انك تمنع المي تجي
it's raining, heavy raining.
it's raining.
Yeah, it's inside.
فيك تحط sealers او تحط on the outside of the concrete. That's the only make the concrete more denser. Design, but that's going to be expensive. أهم شغلة إنك تحط sealers to protect it from the outside.
This is this.
I mean, في different. مثلا فيك تحط شو بيقولوا ضمن الميكس ديزاين to make it more denser. مثلا في عندك شيء اسمه Cybex أو Kryton. هذا you have to talk to those people.
I mean, the protection is the most important now.
Yeah, protection is the most important thing.
Is there any some technique or best practices around the world? In some cases, subdivisions during the heavy raining.
Right.
Because we have actually, it's even that. This is maybe will cost like a budget.
It is expensive, I know. حتى America, they have a lot of issues with flooding, with issues. Main thing is from the outside sealers. If you can seal it, or any cracks, prevent any cracks. And أول شيء detailing, when you do new design. لا تستخدم smaller parts, closer. يخلوا الكراكس يكونوا أصغر. يخلوا الكراكس يكونوا أضيق وأقرب من تصغر الكراكس. That would be one of the best practices. Use smaller parts closer together. حط sealers وخلي تكون الميكس ديزاين dense. يعني حتى permeability. Permeability has to be low.
Existing buildings, maybe buildings 30 years more than 8 years.
We have to look at what type of flooding are you talking about? Are you talking about like a river passing through and you have standing water, or just rain? If you're talking about standing water, one of the best practices is also to make sure that your soil or your ground is moving away from the structure, not moving towards. So you have to do some work on the outside of the structure to have it to move away from the structure so that it doesn't move in. We have مثلا في US, we have like residential homes.
That's mean some trenches.
Not only trenches, just make that whole ground that moves away from your structure at a slope of minimum 6 millimeters per 300 millimeters.
I saw the Louisiana experience during the Katrina.
Yes.
لا يعني ده يعني بس لانه بريك تايم
بعد بعد الجمشة بعد الأول يجي
هاي البزنس كارد كمان.
نسخة يعني
اهلا وسهلا شرفتني خالد نحن.
أنا اسمي أبو خالد.
اهلا وسهلا.
أنا بالوزارة إذا بتشرفنا إذا ترى بعد بكرة هيجي تشرفنا.
لا والله أنا بكرة ماشي. أنا بكرة مسافر لمصر.
فعلا شفت الندوة.
إن شاء الله المرة الجاية إذا جينا وتشرفنا هون نجي نعمل كل
washing for instance. عندنا عمل قدمناه. إن شاء الله.
Otherwise, we'll not start out the system.
Yes, I know.
So that's the.
Test. Okay. Okay, let's continue. Again, as I mentioned, if you have any questions, please stop, and I will address those questions. If they take too long, I will defer you till the end. One thing that probably I did not mention, and probably most of you don't know, that Dr. Ahmad Shuraim and I were colleagues together at the University of Michigan many years ago. So now let's go into Chapter 6, although he says Module 4, but we'll talk about Chapter 6. We'll talk about assessment, evaluation, and analysis. Again, we said that we need to perform structural assessment if the structure is unsafe or if the capacity of the structure is questionable. So when you look at the structural assessment, we have in-place conditions, we do the evaluation, and then the rehab strategies. In-place condition. We talked about review of available documents, and we did the visual survey. Now, what about the material properties? How would we go about those? How would we determine what's the actual material properties in the structure? Do we do destructive or non-destructive testing? And how do we perform the analysis? So one thing is, if we're looking at the structure and we see deterioration or distress in the material properties, then
there's only one way to do it is by doing physical testing, okay? Because whatever is on the drawings telling you, well, the concrete strength is 40 MPa, it doesn't really do you any good because the concrete has deteriorated. So you need to find the actual material properties. If it has not, then you have two options. You look, if you have the actual documents, the contract documents, then you can use whatever material is listed on those documents, but preferably do the physical testing because, again, you will have the as-is. We all know when we place the concrete, concrete will gain strength with time, right? So we need to find out the actual concrete strength. And if we don't have anything, we don't have the material properties, then there are some historical values that the committee came up with, and those are very conservative. I would not recommend to use them because, as I mentioned, they're very conservative, but they're available for do what you call the preliminary analysis. But again, physical testing would be the appropriate way to move forward. So in all, physical testing would be the way to obtain your actual material properties. So we talked about existing drawings. There's no need. Historical data. If we look at the historical data, you look at those data here. They're based on era, and that is based on US construction. So if you're using here in the kingdom, I would recommend that the committee would come up with what were the concrete strengths for a particular era. So you will look at it. So you will make the changes based on your needs or what was the construction practices at that time. And as I mentioned, those are very conservative. If you look like from 1970 to present, they're using like column strength of 21 MPa. I mean, who uses that nowadays? I don't think anybody's using it. But they are conservative. They're just looking, again, at being on the conservative side. So it is really advantageous to do what you call a testing. The same thing when it comes to steel. If you have no information at all about what is your steel strength for a particular era, then the code says you'll take the lowest yield strength. Again, for being conservative, because we don't have any information. For example, if I come between 72 to 74, I have all that steel that was available to me at that time. But if I don't have the drawings, I don't have any information on the steel, the code tells me I would take the lowest. Or doing destructive or non-destructive. The code allows both. Actually, let me rephrase that. Non-destructive testing by itself is not acceptable. So you cannot rely just on non-destructive testing. You have to do destructive testing, and then you calibrate your non-destructive equipment against that actual tests that were performed. So if you look at in-place concrete strength, usually those are quick, easy to do, and don't take much time and are inexpensive. But calibration is required. For example, if we take the Rebound Hammer, this Rebound Hammer is inexpensive. The advantage, it's inexpensive and quick method. But you know it's very unreliable. It depends, you know, if you apply it vertical or if you have it at an incline, it would give you different test results. If there are what you call it, type of cement. If you hit the cement, the paste, or the aggregate will also give you different test results. So this one, maybe it's a good tool to provide you sort of a comparison between the material in this location versus that. So it's just a comparison between the different material within a structure, but does not give you the actual concrete strength. Although the manufacturer may give you sort of a calibration telling you if you hit that rebound number, then that's your concrete strength. It's not acceptable because there's a lot of variability in that, with that equipment, with that instrument. The other one is the Windsor Probe. That one is more accurate, it's more reliable. And what you have there is you have sort of a pin that you shoot into the concrete that penetrate the concrete. And based on that penetration, it will give you the concrete strength. So, excuse me? Okay. The advantages that it is simple to operate, it's durable in maintenance, it's insensitive to surface condition,
The limitations are that your member has to be minimum of 100 millimeters. And it's not recommended for lightweight concrete, nor for lower than 28 MPa. And don't use it on edges and corners. Do you know why? Or can you guess why not? Because you're shooting that pin right into the concrete. You may spoil it or you might crack it. So that's also another method that is quick. And as I mentioned, those are acceptable after you have calibrated it. So you cannot use it just by itself. You take cores, you test those cores, you get your actual concrete strength, and then you calibrate those equipment against that, those tested cores. Pull-off test. That is one of the most used method to test overlays. So if you have an overlay, you get what you call the direct tensile strength. You have this cylinder where you adhere it to the concrete, then you drill around it, and then you pull. And you'd like to have your failure within the substrate, which is the existing concrete. That's where you'd like to have your failure. If you get your failure within the interface, that means you don't have good bondage. Not necessarily, but most of the time you don't have good bondage. So you'd like to have the failure either in the new overlay or in the existing, but not in the interface between the two concretes. Or you can have the pull-out. The pull-out where in new concrete it's used if you're using, for example, if you have post-tensioning to get your concrete strength, or if you have in post-installed, which is called capo, where you drill, then you extend your drill inside, enlarge it, and then you have this expandable cylinder, that device, you let it go through that hole, and when it reaches that enlargement, that expandable head will expand, will hit against those pockets, and then you can pull, you'll get your concrete strength. So there's different methods of determining the concrete strength. And there is the chart that you get from the manufacturers, which will determine your concrete strength, your pull-out force, and that will be reflects what's your concrete compressive strength. You have the stress wave method, and here where you have the input, and here you have the receiver, and that will give you sort of an indication of the approximate the in-place strength, if you have corrosion in your bars or not, if there are any voids, honeycomb voids, or the member thickness. This is a very old method. Do you still use that? What you call that chain dragging? Is it being used here? It's being used quite a bit in the US to find out, on bridges, to find any delamination, where you take a chain and you drag it over the bridge, over the road. And it's inexpensive. It's just done by labor, but just by the sound of it, if it gives you a hollow sound, that means there is delamination. Again, it's simple. Its mapping is that it's not that difficult. Training, it's limited training, not much of a training. And it's quick. The disadvantages, it cannot pick up the onset of delamination. If when you're doing it on bridges, traffic that is driving nearby may affect that sound and may affect the outcome. And if you have asphalt as an overlay, it's ineffective. And as mentioned, because it's done by a person, it's used sometimes it's subjective. And cost of labor is expensive in the US, so that's why we have labor intensive. We have the ultrasonic pulse velocity. Again, here you have the transducer, you have the receiver. So you have to have access on both sides of your member, where on one side you put the transducer, one side you have the receiver. You apply from here a pulse. You receive it on the other side. The quickest distance between 2 points is usually a straight line, right? So if there's nothing, it will be a straight line. If you have, let's say, void, then the time from transducer to receiver, it's a little bit longer. Or if you have a crack. Here's a picture showing where you have here, let's say, the transducer, here's the receiver, or vice versa. And you have, it's affected by the aggregate type, amount of aggregate, and the bar layout. Bar location, it's always important to know when you're doing any repair to determine where your bars are, right? And a quick instrument to you, or an easy instrument and inexpensive, is the cover meter. So with the cover meter, it's not usually that easy to determine what you call the bar size. So unless, for example, you chip a little bit, you determine your depth, and you find out what your what your bar diameter is, then you can, based on that, the relationship, you can determine the other bar sizes by estimating it. The advantages, it's high accuracy, not influenced by moisture, and it's actually low cost. The limitations, again, if it's limited, if your bar are in a depth greater than 100 millimeter, if you have multiple layers of bars, cannot identify that. And also, if you have a lot of bars, then determining the size and spacing of that bar may be difficult. GPR, that's it's very widely used, and the results are usually accurate. I've used that equipment on many of my projects. The one that I mentioned earlier, that where the owner had put a lot of cabinets around the slab, around the column, were initiating punching shear. We used this equipment, and we found out that they had also other issues, that the slab was post-tensioned. It's based on the drawings, it's supposed to have a 25 millimeter cover, or actually less. It was supposed to have 125 millimeter cover. It had more than 25 millimeter cover. So the capacity also of that slab was reduced, and eventually we had to reinforce the slab. So that will give you sort of a map of the whole layout of the reinforcement. So it's fast, it's reliable, and repeatable. The limitations, again, it requires trained personnel. So the people who are doing it needs to be trained on that equipment. Weather, if it's cold, you don't have that issue here, may also affect it. You don't have de-icing. And influenced by depth and spacing of bars. Again, if the bars are deep below the surface, or if they are closely spaced, that will affect the reading. Durability of concrete, we talked about the carbonation. Again, if you take a sample and you apply this material, the phenolphthalein test, you apply it on the core. If it changes, if it becomes colorless, that means there is carbonation, and you can determine how far the carbonation have penetrated into your concrete. But if it turns into pink or reddish, that means you don't have carbonation in your concrete. Again, going back here, we have quite a bit of documents, ACI documents, that talk into much more in depth about those tests, how to perform them, and the advantages and disadvantages of those tests. Let's take a look at destructive testing. As mentioned earlier, destructive testing is the only method acceptable in the code, but you can supplement it with non-destructive testing. So non-destructive testing by itself is not acceptable, but you can correlate between the non-destructive and destructive testing. Because if you also take a lot, actually the code encourages to do non-destructive testing after you have done some destructive testing. And the reason, if you just rely on destructive testing, you take a lot of samples, you may jeopardize the integrity of your structure. It becomes more like a Swiss cheese, right? Because you take too many samples, it will weaken your structure. So cores have to be taken from sound concrete. So if you see a crack, don't try to take your cores where the crack is, trying to determine, because I want to see what's exactly there. No. When you take your cores, take them away from cracks where you have sound concrete. That's where you take your course from. Locate your bars before taking your course. The course should not include any reinforcement. And when it comes to concrete, use minimum 2 cores. And if you take the cores, let's say in a column or wall, where would you take them? From the top, bottom, or from the middle? Any volunteers? In the middle. Why? And why not? The middle is right. Correct. Middle is correct. No, actually, what they found, again, that if you take it at the top, your concrete strength is about 15% lower. Okay? If you take it at the bottom, your concrete strength is about 10% higher. And why is that? Because when you place the concrete, most of the aggregates will go down below, right? So you had denser concrete, stronger concrete. And the top, you don't have much aggregate. You have actually the lower quality of your concrete. So you have it less. So the best thing to take your cores in the middle. You see this equation. So the code, just quickly, briefly, many times when people take cores to determine their concrete strength, what do? They take the average of their cores, right? That's what engineers usually do. I take, like, say, 3 cores. They came 24, 26, 22, so the average is 24. So that's what I take my concrete strength. Well, when you as an engineer, when you specify on your drawings, I need 40 MPa. The batch plant will design the mix for exactly 40 MPa, or they design for 48 MPa. And they go through the statistical analysis to reduce it down to something that is measurable with 40. The same thing here. So here it's based, you see on that table, here we have the coefficient of variation, and we have also these factors. So as the number of your cores increases, that factor decreases. And suppose we take an infinite number of testing where this one would go to 0. Then if I resolve this equation, then the best thing, what we call here, is the equivalent concrete strength will not exceed about 86% of your average core strength. So this here, FC bar, is the average of your cores. So if I take an infinite number, the best that here will reach is about 86, 87% of your average samples. And as I mentioned, you can supplement that with non-destructive testing. Steel, when I check for steel, I need to determine the size, number, confirm location, and effective depth. So when I take my samples, where I take them from, if I'm looking at flexure, if I'm taking for longitudinal bar, where would I take my samples for simply supported? You try to take them where you have the minimum strength, right? Which would be closer to the ends. That's where your minimum strength is. And for shear, where you have the minimum shear, which is usually for uniformly loaded, it's at midspan. And if you have walls or slabs, if you take the samples, take them, let's say if you have 2 bars or 3 bars next to each other, when you take them, have a difference of about the development length. So you take minimum of 3 samples from different segments and take from members being evaluated. Again, for steel, we have also an equation, with, as shown here, the same thing, Fy bar, that is your average from the samples that you've tested, and that would be your equivalent yield strength from that equation. I will not go into it, but again, if you use a very high number of samples, your equivalent yield strength would be about 85%. Let me take an example and show you how we manipulate or how we use these equations so far and using with the reduction factors. Here it's an actual example. Here we have a structure that was built in the 1930s. It's an inverted T. There's nothing wrong with the structure. The structure is fine, but the owner wants to add a mechanical unit. Okay? And as I mentioned, no drawings, nothing. So they came in and they measured the member sizes. They used the cover meter and chipped away, and they found that it has 2 number 16 top and bottom. Material properties are unknown. So the engineer has to do some evaluation. So rather than jumping directly into testing, he said, let me check with the historical data. Am I fine? Do I need to go through? If I do my analysis with the historical data and the structure is fine, then I can save the owner the hazard of doing destructive testing. So I went to that table. It was built in the 30s. So the concrete strength is 14 MPa. Going to the steel, again, 30s, the lowest concrete the lowest yield strength is the 230. Because he hasn't done really the material properties, although he checked the member sizes, we use the lower reduction factors, the 0.9 and 0.75 for flexure and shear, respectively. If I do my demand capacity ratio based on the historical data, it's 0.9. It's less than 1. That means my structure is okay. It's safe, and it satisfies the original code requirements. But when I added the unit, it came out to 1.27, much higher. So that means I need to reinforce the structure, right? So rather than going in and strengthening the structure, the engineer said, let me do some testing. Let me go through a testing protocol. So they did, he took 8 samples, and they found out that the average is 42.9. By using those values, so forth, the average or the equivalent concrete's compressive strength was 35. And if you look at it, it's more than twice the historical data. So you can see with the testing, you get a little bit of advantage. Now let's go to the steel. Took 4 samples, and the equivalent yield strength is 229, which is very close to the historical, which was 230. And by the way, this is an actual project. So it was 230. Now going back, now because I have the actual member sizes, and I did determine my material properties, now I can use the higher reduction factors. Okay, see how the code now works? Because I have my material properties, I have my member sizes, I can use the higher reduction factors. Now I did my demand capacity ratio, it's 1.06. So it's still greater than 1. And if you remember when we talked earlier in Chapter 4, determining the design basis code, if we have changing in capacity and we have increase in loading, then we use the current building code. So the engineer now is justified to strengthen the structure. But rather than strengthening it to the level of 1.27, the engineer now needs only to strengthen by that difference of 6%. So the strengthening is much less. Okay? But because it is very close to 1, the engineer said, if I use more test data, I might improve my probability. As you remember, we have that K sub S or K sub C. With the increase in samples, it will decrease, and it will give me a higher equivalent number. If you remember, for the steel, it was, for 4 samples, it was 2.3, I believe. Now he said, I'll take 2 more, taking 6. So that K sub S dropped to 1.7. And the equivalent yield strength increased from 230 to 248. So doing my design capacity ratio, it's less than 1. And I don't need to do any reinforcement anymore. So what did the engineer do here? He not only saved the owner a lot of money, which makes the owner very happy, but also the downtime, right? Because when the structure is closed, that means the owner is losing revenue, losing money. So by going through this exercise, maybe it did cost the owner a little bit of money for the engineering and for the testing, but overall, it saved the owner a lot of money when it comes to repair work, because that's costly. And on top of that, also, it saved him downtime because the structure does not need to be closed. Evaluation. The engineer needs to determine and confirm the cause now after they have done the testing, evaluation, and observing. Now they have to determine and conform the causes of the deterioration, right? They have done the testing, they have done destructive, non-destructive testing, they've chipped. So now they have to confirm the cause of the deterioration.
Also from the testing, they can determine the extent of the deterioration. Is it just where we have the crack, or has it extended beyond the crack? Or is it also in depth? How far does that crack penetrate into the member? We'll have to evaluate the different causes of failure, right? Has to look at all the median measures, and also predict the future deterioration of the repaired or unrepaired structures. So if a member requires repair, the engineer has also to determine if similar members also need to be repaired. Maybe the deterioration or distress is in that particular member, but other members who have similar design, similar capacity, similar loading, do those also need to be repaired? That's also a judgment call by the engineer. Let's talk about rehab strategies. We talked about those different steps. Now we need to perform the analysis. So when the engineer performs the analysis, many times the engineer would go, well, here I have the drawings, I have the member sizes, and they model them as is. Well, what the engineer needs to do when they're doing the analysis is to reflect what's actually there in the field. Needs to model the actual structure. If there are any cracking, we'll need to show that there is lower stiffness. If they have any additional members, adding columns or removed columns, so all those need to be reflected in the model, putting the as measured dimensions and the actual material properties. So the model has to reflect the actual structure that is that's existing. Also, if there were any previous repairs to the structure or modifications, those need to be included. You have to have that continuous load path. Also, when you're doing the analysis, you have to check that the structure or how the repair is going to be done or performed. So with the analysis, you have to look at the construction sequences by adding material, removing material, reducing the member sizes. For example, if you are repairing a column, you have first to chip, remove some of the material from the concrete that will reduce the cross-section. So that needs to be shown or reflected in your model, those different steps or steps as you progressing. So it is important for the owner also to engage the contractor at the start of a project, because the engineer is sitting in the office thinking for himself, you know, I think the contractor is going to do this, this, and that. That's how he's going to do the construction. But the contractor may have a different idea, may think differently, may have other methods of doing the repair work. So it's important for the engineer and the contractor to talk together so that the engineer does not have to repeat the work and redo the work, because that doesn't make anybody or everybody happy. And many times when the engineer did the testing and the evaluation, but he's still not sure that the structure really, that he has really addressed all the issues within the structure, that he knows why the structure really is deteriorating or falling apart. So in this case, one thing to do is to do some testing, load testing. And load testing only does not need, it's not only for when you are not sure of how the structure was put together or the existing condition of the structure, but also after the repair is done, you may also question the repair quality, or if the repair work was done properly, then you also do some load testing. If we have time, I can show you a project that was done only about 12 slides. If we have time towards the end, I can go with you through an example. So it's also to confirm the effectiveness of proposed report. When Committee 562 was putting this document together, that standard, they thought that they also need sort of another standard for the load testing. So Committee 437 came together and they put a standard, just a protocol how to test load a structure. So that's also a document by itself that works with 562. Here are other documents
by ACI and non-ACI organizations that deal with the repair, evaluation, assessment of structure. And as you see, those are all, with the exception of 41 and 37, those are standards. 37 really gives you the construction loads. 41 is the assessment for seismic, but everything else are reports and guides. Let's talk about design of structural strength, structural repairs. So what is the purpose of repair? The primary objective is to restore the structures, right? The structure's integrity, safety, and serviceability. So when you put the structure together, you need to have, first of all, that the people are sure that it is safe. Okay, that's your first thing, is safety is number one. Then serviceability. You don't want to walk on a slab where it's bouncy, right? Or there is high wind, you feel the structure is moving. So you need to have serviceability and safety. And definitely the integrity goes with it. We need to satisfy that my capacity is greater than my demand. You have to check the lateral and vertical deflections, vibrations, cracking, and so forth. So those all need to have. The structure need to have adequate stiffness to limit all those the deflections or vibrations and cracking. When we look at structures, the most important thing in any structure when we have failures, where do the failures usually occur? Usually at the joints. That would be usually the weak point in any structure. The joints are the main things that you need to look at or ensure that that structure is working together properly. As I mentioned earlier, during my 20 years of experience, I haven't seen any structure failing in flexure. Okay, or haven't heard of any structure that had flexural issues. But when it comes to connections, if you look at earthquakes, where do most of the failures occur? Really at the joints. And so when you're adding new members to a structure, the connections of that new member to the existing structure is important. You need to ensure that it will transfer the load properly from that new member to the existing, or from the existing to the new. So when we look at durability, we have to look at service loads. When it comes to repair, we have to look at service and ultimate. And also for non-structural that imposes life safety, we have to look at service and ultimate. And as I mentioned, when we look at the repair, when you're adding like an overlay or new material to an existing material, the repair is as good as your surface preparation. So if the surface is not well prepared, you're not going to get a good repair. Your repair is going to fail. And if you remember when we talked earlier this morning, we talked about the failure rate of repair. It was about 70% within 10 years. So the bond strength is influenced by the quality of surface preparation, the strength of concrete substrate, the characteristics of repair material, strength of repair material, construction procedures, and time-dependent factors. And what do I mean by time-dependent factors? For example, if you want to have an overlay, right, and you apply epoxy on the substrate, and you leave it for a couple hours, and then come back to put your overlay, what will happen with that epoxy? It will solidify, right? It will lose its stickiness or its bonding. So when you come with the overlay, will it bond to the existing? It will not. So you'll get that delamination, or it will not bond, so it will not work together. So that's what's meant with the time factor. So when you apply whatever material, that you go directly or quickly to adding your overlay. Like you look at a bond example, that's also from an actual project that is in Chicago. What we have here is a 9-story building structure built in 1971. It has 200 millimeter thick lightweight concrete slab. The concrete strength is 26 MPa. Steel is 420 MPa. As mentioned, Chicago, that it means there is snow. Snow, that means they spray salt. Salt is carried by the cars into the parking garage. When it goes into the parking garage, there is chloride contamination. That means steel corrodes. So here, showing some here delamination of the underside of the slab, here the top side of the slab. So they took some, for testing, they took samples to test the concrete compressive strength and the chloride content within the concrete. Well, the concrete strength, the actual matched the design, so that's fine. So we're using the 25.9 or 26. The chloride was found to be over the full depth, and in some cases they found that the cover was not sufficient. For example, they required 25 millimeters, it was less than that. So it did not satisfy the code requirements of that time. So the engineer solution was to remove about 90 millimeters of that top deck of the slab, which is about half the slab thickness, right? So they took about half the slab thickness away. And they wanted to replace it with bonded lightweight concrete. So they want to remove all the deteriorated concrete, clean surface by blasting or water blasting, ensure that surface is properly roughened. So when we talk about roughening, you need, what we mean by roughening is between the high point and low point of the roughened surface. So you need to have what you call it a high and valleys. So in order when you add your overlay that they bond properly together. So you don't need it to have a smooth when you remove concrete. If it's smooth, that means it's not good surface preparation. Good surface preparation when you have those highs and lows in your concrete. And what a good number is about 6 millimeters. And all the loose material needs to be removed. So the way to remove concrete is either by mechanical removal, by cutting it and removing, as we see here. Usually that is done for small areas, like in this case here where you have this shape. That shape for cutting is really not good, is not bad. And the reason being because you have too many corners, right? Having too many corners, that will create weak points and concrete may crack, or like something like that. That's no good. A better way of cutting the concrete would be to create sort of square or rectangular sections for concrete removal. Or you can do chipping, okay? Chipping is another method, and those equipments are really big and expensive, and they may not work well, or you may damage them if you have reinforcement, because it has what you call like steel teeth that grab the concrete and take and chip away from the concrete. So if you have steel that is close to the top, you may pull some of the steel out with you, which may damage the equipment that is expensive. And here is shows what the equipment does. For example, here you see the roughened surface, which is top and bottom, because you can manipulate it, you can control it. It's about 6 inches. But one thing when you have with this chipping, it also eats through it takes the aggregate, it cuts through the aggregate. So it may create some micro cracking, which is an undesirable characteristic when you have an overlay. Or you can use hydro demolition. Hydro demolition when you apply high-speed water on your surface. This one has the advantage, here if you look at it at the surface, it does not cut through or does not damage the aggregate, does not create micro cracking, and you'd like to have this aggregate. You like to have that aggregate so you get a good grab between the new concrete and the existing concrete. So you have that amplitude. And as I mentioned, there's no micro cracking there. So the contractor decided to go with the hydro demolition, which results in rough, irregular surface. It minimizing the surface micro cracking. It exposes the aggregate so they are not fractured. And if you have low strength concrete, it will remove that concrete. And minimizing vibration to surrounding structure, and preserves and cleans reinforcing bars, which is important. So if you have any bars, because of that removing 90 millimeters, you're exposing your reinforcement. And we mentioned that bars were corroded, so it will clean those bars. And it will preserve them, will not damage those bars. So before moving on, the engineer thought that we need to do some testing. So they took panels where they tested them, they placed the concrete, and they tested those panels. And that's what they came up from the tests. They took 2 bays, or actually here, total of 6 bays. And here are the test results. They were between 0.76 and 1 MPa. So the engineer was happy. That's what he was looking for. He was looking for that number. Because if you look at those low, where the failure was at the surface of the substrate concrete. So it wasn't really at the interface. So here they started now here with the construction work. Here's the equipment that's doing the hydro demolition within the structure. So after they have done some work, the engineer said, let's stop and check what we have done so far as the quality control. Do we have good bondage? Do we have proper bondage? So when they did some testing, they found like tests that were very low, 0.22, and it is at the interface, 0.54, okay? So very low test results. So that was alarming. So the engineer stopped the work and tried to figure out why they got that low test results. So they took a few cores, they took it to the petrograph and to analyze it. And what did they find out? If you look at this picture, this is the existing concrete. This is the new concrete, the overlay. And what do we see here? They found debris. They found loose material, which what they did, it created a debonding between the new and the existing. So that means the contractor did not do a good job of cleaning the concrete after the demolition or after removing the concrete. So the work was stopped, meetings were held, and the outcome was that the contractor needs to do a better job and needs more supervision. So they added more inspectors to closely examine the work of the construction. So they continued and they did some more tests after a while, and they found out that the test results increased, and the engineer was happy with those test results. Because here, when we have the low, it was in the substrate. It wasn't really at the interface. So the engineer was happy with the test results, and the project continued. And they took here samples where you had low, low results. And they found out here from the petrograph that there is very good bondage and there is no debris between the existing and the new material. Here are some of the other ACI documents that also would provide guidelines in the selection of repair materials. When we take a look at strengthening or methods of strengthening, what is allowed by this code? We can use conventional strengthening method. We can use concrete enlargement, and we can use steel enlargement. Sometimes concrete and concrete work very well together, but sometimes it's easier to use steel. But you have also to look at the structure itself. Can I bring in those big steel members into my structure? The maneuverability or the access into the structure. Maybe steel structures will not work, so I need to bring in, my strengthening has to be done with enlarged concrete sections. Post-tensioning also is acceptable when it comes to repair, external post-tensioning. Or FRP. Is FRP used here? Excuse me? But not for repair. You use it for, okay. So FRP, it's another material that can be used for repair. It comes fabric, bars, or plates. When you use as bars, we call it NMS or NSM, near surface mounted, where you create what you call slots in your member, very, very narrow slots. You fill it with epoxy, and you put these bars.
FRP has also limitations. If somebody comes and tells me I can strengthen the structure by doubling its strength, I tell them, hey, wait a minute. If you tell me 30, 40%, I'll accept that, but not twice the strength, because it has limitations, okay? So FRP it's a very good material. It's lightweight, it's strong, but it also has its limitations. You cannot use it for example, doubling the strength or going like 60, 70%. The one thing about FRP, it's very thin, that it will not change the dimensions of your member. And it's versatile. You can apply it as shown here. Here are plates over slab, or you can use it as a fiber around columns or beams. And they could be bond critical or contact critical. ACI has also those different documents when it comes to FRP, externally bonded, internal, or internal PT. By the way, as an ACI member, all those guides and reports are for free download for you. So we talked about here the repair. When it comes to analysis, you have to do the same thing with the repair. Now we talk about durability. What is durability? If somebody asks what is durability? It is defined in 365 as the ability of a material or structure to resist weathering action, chemical attack, abrasion, and other conditions of service, and maintain serviceability over a specified time or service life. Or in other words, I have my material properties in that element or in that structure, and those material elements are maintained over that period of time, irrespective of what the environment is imposing on that material, maintaining those characteristics. I mentioned earlier today that 201 is writing a standard on durability. 365 is also writing a standard, started at the same time, to determine the service life protection. Actually, that came also from one of those seminars that we were doing. Somebody came and said, well, if I'm designing, am I designing for 80 years or 100 years? How could I ensure that my structure will last that long? I need something in writing. I told him, I don't know. Then he said, well, where I work, it was outside the US. That person said, well, where I'm working, the authorities wants me to sign a piece of paper that my design is good for 100 years. And I cannot do that because I don't have anything in my hand that I can refer to that tells me that my design is good for 100 years. I told him, well, you have this document. He said, well, it's a report or a guide. It's not mandatory. It's not accepted by the authorities. I told him, well, sorry, I don't know what to tell you. And then we got also several questions because at ACI website, there is a link. If anybody has a question about a document, about provisions, they can submit it. And within 48 hours, somebody will respond to that question. So we also received quite a few of those, we call them the technical inquiries or technical support. We received also at least 2 from different individuals also asking about the life, what you call the service life of a structure. So it was relayed to the committee, and they are undertaking this journey of writing a standard on the service life of a structure. Now we talked about durability. What type of material would I use? The material, as I mentioned earlier, there's a lot of material out there by the material suppliers. But you as an engineer has to determine what material really applies for your particular condition, for your particular job. All materials are good, but it depends on the situation that you are in. For example, if there's a lot of variation in temperature between day and night or between summer and winter, so when you apply a new material to existing material, you'd like to have that thermal coefficient to be similar of that new material to the existing. Because if there's variation in temperature, there will be expansion and contraction. So you'd like those 2 materials to work together, that they expand together or shrink together. Otherwise, it will be dissimilar, and there will be shear between those two materials and may result in premature failure. Or if you're adding material to existing and you're relying on load sharing, that this new, for example, you took a lot from a concrete column, reduce its size, and you're adding more new concrete to it. So you're relying on that new concrete and existing concrete to work together. So sometimes engineers think of strength, that strength is the most important thing. Well, if you have strength, very high strength, that means your modulus of elasticity is different than the lower strength concrete. So when they try to share loading, what happens? Where would the load go? It will go to the stiffer material, right? So that will be loaded first. And when that is loaded first, that means most of the load is going there. So there is the probability of that newer material or the stiffer material to fail before the other materials start sharing with the load. So also when we talk about shrinkage, every job, when an engineer puts a new material in, he says, I want to have non-shrink grout or non-shrink material to be added to this structure, because you don't want to have that shrinkage of that material, because it will result in some stresses between the new and the existing. So factors as affecting the durability is the mixture proportions, presence of or positioning of reinforcement, detailing, curing. So different factors affect your durability, positive or negative. So the design service life is really established by the engineer in consultation with the owner. Let's say the owner has a building. He only wants to use it for another 10 years. Then he wants to demolish it and build a new building. It doesn't make sense for the engineer to come in and design the repair work for the structure to last another 50 years if the owner only wants it for 10 years. Okay? So this thing needs to be discussed between the engineer and the owner about the desired design service life. But in all, you have to maintain the strength, safety, and serviceability. So let's talk about causes of degradation. We talked about the mechanical, chemical. We addressed those. Compatibility of materials, cover. Cover is important because if you don't have cover here, like in this case with that column, you notice there is not enough cover, so the steel started corroding. Looking at cracks. Cracks are different types of cracks. We have to look at their causes. Why did they occur? Is it because of shrinkage, temperature cracks, or are they because of structural cracks due to loading, settlement? Are they active or dormant? What's the size, orientation, the width? All that will tell me. If they're straight up, they may be not as critical as if they are inclined, especially at the support, or if you see cracks around the column versus cracks away from the column in the midspan. So those issues that the engineer has to look at and evaluate and determine those cracks. For example, here on this side, on the left side, where you have random cracks, could be just from shrinkage and temperature. Those may not be as critical as when you have those inclined cracks at the edge of a girder or a beam. That means here we have shear cracking. That needs to be addressed, and that will affect your strength. As mentioned, we need to look if it's active or dormant. One thing is, for example, to measure the width of the crack over periods of time, or put that device and see how the crack is moving. Active cracks means we need to take some actions. It needs to be addressed, needs to be corrected. Dormant cracks, that means that crack is not moving. There's no deterioration or there's no movement in the structure, but a dormant crack could become an active crack in the future. Corrosion. Corrosion, as mentioned earlier, it's one of the biggest issues that's
that affects the construction industry or buildings in general, and it costs a lot of money, not only for repair, but also on downtime and revenue. So if you have corrosion in your bars and you do not take care of corrosion or remove the source of corrosion, it will continue even if you repair it. For example, if you have, let's say, spalling in your concrete because of corrosion, and the owner just brings a contractor and patch it, what will happen? That repair will fail, right? Because you haven't really taken care of your corrosion. That repair will fail. So you need to address corrosion before looking or repairing that element. So if there's corrosion in your reinforcement, would you maintain your bar, use the bar as being effective, or you will determine that the bar is ineffective? Well, it depends. You see here this document here called 364.1T. T here stands for Tech Note. I mentioned earlier R stands for report or guides. T here is a Tech Note, and that is a very small document, about 3, 4, 5 pages long, and where the committee will pose a question, and they will try to answer that question. So that whole document just about answering one question that is relevant to the construction or the design profession. Like in this case here, it says rehabilitation of structure with reinforcement section loss. You can't read it here, but the question is, how would we determine the actual or the effective bar diameter, the existing bar diameter, if it has corroded? So if you notice here, here's the question, and here is the answer, and here is a discussion. So they give you the question, the answer, and they give you then the discussion why they came up with that answer. And so if you read this document, it tells you if your bar still maintains 90% or more of its bar diameter, you can use it as fully effective. Okay? You don't take any reduction. And the reason being because we have a lot of safety factors, a lot of probability. So we maintain the bar strength. But suppose now those deformations in the bar are gone. What would you do? Then the bar is considered as a smooth bar. Then you have also to consider the development length. You have to consider other issues with that bar. So if you look here at this localized repair. So here, for example, the engineer may have found a crack in the concrete. Came in, enlarged the area of that concrete, took it out, cleaned the concrete, and put that patch. What will happen here, you'll get that film or that protection layer that we saw earlier this morning. But if you have contamination within the concrete outside that area, because here now concrete has high pH, but the concrete around its surrounding, if it's contaminated with chloride or with carbonate, what will happen? That will accelerate the corrosion of the bar outside that area. And what you will see on the tops, on the surface of the concrete, you'll see ring cracks or ring effects. We call it the ring effects, or we call it the halo effects. So there are round cracks around that repair area. Surface treatment. If you have corrosion, best thing is to take the whole thing out. But that may not be that practical. May be expensive, and sometimes it's not necessary. So there are other ways or other methods of protecting your steel, using non-metallic coating, metallic coating, inhibitors, or using electrochemical protection. And I will go briefly over each one of them. I will continue, right? To the end. Okay, great. So I will not take much time here. So if we look at sealers, sealers will block the chloride from entering, but it does not block CO2, or it does not address existing contamination. And that what will happen, the steel bar will continue corroding. So it may delay the failure of the structure, may prolong the life of the structure for a short period of time because of that sealer. It's preventing the chloride, but as mentioned, does not prevent the carbon dioxide or the carbonate and whatever is inside that concrete. The same thing with the membrane. Membrane will protect the concrete from external carbonate and chloride. Will also protect the concrete from water, from moisture entering the concrete, but it will not protect protect the concrete from contamination that's already existing within the concrete, and so the steel bar will continue corroding. There is also that product which they call the migration corrosion inhibitor. Has anybody used it here or is familiar with it? Just raise your hand if you are familiar with it or it has been used for repair. Okay, how does it work? I mean, did it work for you, or has it worked fine? Did it protect the reinforcement? Okay, what we have, I mean, some people say it really works great, others say so and so. So I myself don't know, but some people said, well, if you applied, it works great. Those corrosion inhibitors, they work great with new concrete. If you have it within your mix as an admixture, it works great because it protects the concrete. But applying it at the surface, what I've been told is that, well, as far as that product migrating down into the concrete may not be uniform, or you don't know where it stops. It may continue beyond where your layer of bars is, so it does not provide the protection. So I don't have the data, and I did talk to some material suppliers and told them, if you have any data, please share it with us. Yes?
I would just like to give the chance for somebody to ask a question. The timetable will not.
Right. Yes, and that's why I asked you. Yes, yes.
So just try to remind them if somebody
yes.
have a question.
Sure.
بس حبيت أنبه للشباب أن في البرنامج المحاضرة أن من 12:15 إلى 1 كانت الأسئلة والنقاش، لكن فضل الدكتور أنه يكون يدمج المحاضرة مع الأسئلة، لذلك اللي عنده سؤال أو شيء يقدر يعني يسأل من الآن، يقدر يطرح سؤال على الدكتور.
Okay, for those, I just repeat what His Excellency said, is that if the program indicates that the presentation should end at 12:15, and from 12:15 till 1 o'clock, we have questions and answers. I thought it may be more engaging if I'm talking and if you have questions while I'm talking so I can respond to your questions. So he's just reminding you if you have any questions to ask those, and reminding that we are deviating slightly from the program.
Excuse me, Mr.
Yes.
Khalid. First, I would like to thank you for your tremendous presentation. It's incredible, really. I would go back a little bit just to ask about the categories, 2 categories of how to apply or where to use this code. One is engineering issues, and the other thing is construction issues. We've faced here some cases that the major structural mistakes are there, where we don't know whether to apply the reparation method of statement or not. Because this is really, I'm going to give you an obvious example just to illustrate this. يعني one of the projects that we visited to evaluate the safety of the structure, we found that the drop beams are actually placed on the wrong way, which is to the يعني longest span, not to the shortest span. This is يعني part of the يعني 101 structural engineering.
Correct.
But we found that the owner is in trouble, and he paid a lot of money to build his own house. So we were actually having hard time to whether proceed with his request or not. So
What was his request?
to see because the immediate cracks, the immediate
Okay, there were cracks.
yes. So the reparation, he was asking, the owner was asking to have a reparation plan for his villa, where a lot of structural design issues there.
Okay. You all heard his question that there was some issues with the design, or the contractor, the way he built the structure was different from what the engineer designed it, right? Yeah. Well, that's an obvious mistake, and I think somebody has to pay for it. And definitely, if the engineer did the mistake or the contractor did the mistake, it's not the owner that need to be held responsible for that mistake. So, but again, we're talking about life safety issues, and so it needs to be repaired, or something needs to be done, either by adding beams in the other direction to support it, or to mitigate these deficiencies. But it cannot be left. And as you mentioned, I mean, the owner has paid a lot of money. I sympathize with the owner, but he should not be held responsible. It's somebody has to pay for it. So yes, you can use this code in order to come up with the strengthening plan for your structure. Did I answer your question? Okay. Yes.
Assalamu alaikum.
Thank
you, Doctor, for your interesting presentation. My question, recently, as you mentioned, that corrosion is the most popular problem in structure. Recently, I think University of Miami doing some research about replacing steel bars with the fiberglass.
Yes.
And this will solve this problem. If you have any information or more information about this, can you explain, please?
Okay, for those who have not heard the question, that research has been done, and actually I know the professor there at the University of Miami. So he's a good person. Using FRP bars in new construction, because that will get rid of all the corrosion. You're correct. Rebars, actually in the US, it's being used, but mainly for repair of bridges, and especially at bends or where you have the girders. For new construction, unfortunately, we don't have a standard yet, although Committee 440 is working on a standard. But it's overdue. It has been for a very long time, and they haven't really come up with one yet. For whatever reason, maybe there is no complete agreement among the members, but it should have come out quite some time. But once we have the code, then we can use those bars. Until then, unfortunately, I can't, because there's always that liability issue. But in repair here, like in this code tells you, you can use it for repair. And I mentioned earlier, you have that near surface mounted bars where you can apply it. For example, also talking about Florida, a few years back, they built a hospital, brand new. What they found out is that, well, the contractor forgot to put part of the reinforcement over a whole bay, forgot to put reinforcement. So what did they do? They went in and they added FRP. They added those sheets to supplement the reinforcement. And the hospital is in operation. It's working fine. Yes? Yes, it's working.
Yeah, thank you so much for your presentation.
You're welcome.
I have a question regarding fire. If a structure is designed according to the code for, let's say, 2-hour fire protection, and a fire happens for about 1.5 hours or so, or let's say 2 hours, what type of strategy will be adopted? Is it safe, the structure will be safe, or it has to be evaluated again?
I would recommend to evaluate the structure, irrespective, because you never know what happens. You need to look at the material properties. As you noticed here, 2 hours, you get 55%. You said 1.5 hours.
Yeah.
So are you 60, 70%? I would like to get my material properties, the actual. I did only investigate one project where there was fire. And it was fire in a plant. So we did, actually it was steel structure, we did take some samples and we tested them. And there was some issues with it. So yes, definitely I would go through a program. I mean, you'd like to sleep safe at night, right? You want to sleep comfortably at night. You don't want to have like second thoughts. Well, I assume like after 1 hour, the structure is safe. But what if there is that small probability that's in your mind playing, you know, what if the structure is still, or the material properties have deteriorated? Is my structure safe? So I would recommend at any point, if you're doing with fire, that do testing.
So if we evaluate and we find that it needs some protection, for example, a fiber, carbon fiber or something of that sort, it need to be further protected again for future fire?
Well, if you remember, I talked about the equations, right?
Right.
I said if the code, if you remember, without the FRP satisfies the 1.2 dead plus 0.5 live,
Yes.
then you don't need to provide any fire protection. If not, then you need to provide fire protection.
Thank you so much.
You're welcome. Any other questions before I continue?
Thank you, Doctor, for this, I would say, amazing lecture.
Thank you.
Full and easy to understand. I have a question with regards to qualifications for engineers to be able to assess the building. We have some certifications through ICI. With regards to assessment and repairing, do we have such a certification or educational program that covers this area?
For engineers?
Yes, for engineers. As you mentioned, we were not educated in the university, so
right.
there must be a way.
Okay. The education that we have when it comes to repair is through those like seminars like these. We're doing quite a few of those in the US. We have them as a full-day seminars where we talk to engineers. We have webinars. For example, you have where you can go to the ACI website and listen to some of those lectures. Currently, for engineers, as mentioned, an engineer has to have the knowledge, the experience, and good judgment. So, as I mentioned, there's no certification for engineers per se to do that, to qualify them to be in the repair. Maybe in the future, but currently we don't have. Actually, in the US, we, as an engineer, as a person who graduates from school, from a university, he's called a designer unless they pass a state exam to be called professional engineer. And that exam or that license would make that person to become an engineer. And to maintain your professional engineer status, you have to go through, attend seminars like these, lectures,
And at the end of the year, you have to satisfy a minimum amount of hours that you have attended. For example, some states require a minimum of 30 hours. Like this lecture being 4 hours would count towards 4. If it's a full day, 8 hours, then those would count as 8. So within the year, you have to take a minimum of 30 hours. For example, I'm licensed in California and Michigan, so I have to submit to those states if they ask me. I have to submit hours showing them that I have satisfied those requirements. So that would count towards your continuing education as an engineer. So that's something that could be probably also used here in the kingdom. Any other questions?
Thank you, Doctor, for your seminar.
Sure.
I have a practical question. If we have a flat slab and we have cold joint, we have two parts, one above other.
So the cold joint is horizontal.
Horizontal, yes. How we can make link with repairing, make link with two layers to work together?
To work together? It's already existing, right? Well, when you have overlay, we mentioned you have to have some friction. Actually, I did not go through it here in the design, but the code tells you that if you have an overlay, you have to maintain certain shear between the two layers in order for them to work together. So in your case, they don't work together.
I need to repair it.
You need to repair it. So you have to think either coming from underneath and probably adding a system. I'm just talking here out loud. I don't know what your structure is, and probably I'm putting myself out there. So either by probably providing beams underneath it to support it, or I hate to go that far, but in order to engage those two of them to work together, it's not that easy. So the best thing is to have something, a system from underneath it, to support it. And the other one is just sitting on top. It's just an overlay, not bonded.
I think if we make
dowels,
put some dowels or something.
Yeah, but how much dowels do you need to put there? I mean, you have to calculate. You have to design that because again, it's shear. It's shear. You have to ensure that because you have two layers that working independently to make them work together. So if you need to provide dowels in between them, you have to do your calculations.
We can make this.
Okay, because you have also to look at the development. Usually, when you put a dowel, you insert it into the bottom slab, and the top slab you have it like bent, right? And then you have another layer of reinforcement. So if I just have dowels, I'm not so sure, but I'm not going to put myself out. So.
السلام عليكم.
عليكم السلام.
لو سمحت دكتور بدي أسألك الرطوبة تأثيرها على الحديد أقوى ولا على الخرسانة؟ يعني أيهما أكثر؟
على الحديد.
على الحديد.
يعني الرطوبة بتدخل عن طريق الخرسانة للحديد.
طيب.
بس ما بتأثر على الخرسانة بحد ذاتها، بتأثر على الحديد أكثر.
طيب. هذا السؤال الأول. السؤال الثاني لو كان أنا
Excuse me, just to translate for those who don't speak Arabic. The question was moisture. Does it affect the concrete or affects the steel? And my response is that the moisture will affect the reinforcement.
في ترجمة دكتور يعني
في ترجمة اللي ما بيعرف الإنجليزي.
اللي ما بيعرف لغة عربية عم يترجموا له الله
يجزيه ما بعرف إذا في الترجمة الإنجليزي عفوا.
لو كان أنا عندي عمود وبدي أسوي له تدعيم يعني بدي أسوي له قميص هل الأفضل إني أسوي القميص بشكل مستقل ولا لازم أدخل حديد القميص بالعمود القديم؟
إذا حطيت القميص كمستقل بحد ذاته، شايف كيف؟ يعني كل الحمولة حامله القميص بيكون منفصل، بس عادة أنت بدك تساوي إنه القميص مع العمود الأصلي يعملوا مع بعض. يشتغلوا مع بعض، بتدخل مثل بيسمون الداولز حتى يشتغلوا مع بعض.
طيب المشكله انه لما عم تحط الحديد الجديد مع الحديد القديم عم تدخله بشكل عرضي، العمود القديم تقريبا شبه عم ينهار انهيار تام.
عم ينهار انهيار تام. ماتوا ساعتها
يعني كمان بترجع للوضع اللي انت قاعد فيه، يعني كمشروع كوضع خاص. اذا ماني شايفه انا اتعرف عليها، ممكن احتمال انك تقيم العمود كله وتحط عمود جديد. اذا الوضع هالقد تعبان مثل ما عم تتفضل وتقول، يعني ساعتها بيكون الافضل انك تقيمه وتحط جديد. بس اذا الخرسانه الموجوده لسه فيها عندها شو بيقولوا، عندها لسه قدره تتحمل، دخل هالداولز، شو بيسمون الداولز، حطهم وادعمه بشكل مباشر. او فيك تحط شو بيقولوا، اذا الخرسانه وضعت لساته صحيح، يعني ما في عندك شو بيقولوا سبولينج او ما في عندك deterioration، انك ممكن تقوي الخرسانه، كتحط الاف ار بي. انه انت بتعرف اذا عندك الخرسانه وقت انت بتضغط السلندر هذا بده يتوسع، بعد اذا انت حطيت هالاف ار بيز ضغطت عليه بيعطيه حموله احيانا ضعف الحموله الاساسيه تبع العمود.
طيب سؤال اخير لو سمحت. بالنسبه للجزرات في الاعمده، يعني بناخذ عينه من العمود مشان نختبرها ونعرف مدى قوه العمود، هل هذه الجزرات اكيد هي عم تاثر على العمود وعم تضعف لنا العمود، فما في بديل عنا انه الافضل انه ما نستخدم جزرات؟
هو على حسب قديش فيك تاخذ جزره، قديش عم تاخذها انت قطره.
يعني 7 سم مثل ما تفضل الاستاذ، او بين 5 و7.
بين الخمسة والسبعة، يعني هذا يعني إذا أخذت 5 يعني الكود بيقول لك تاخذ على الأقل 2. إذا أخذت 2 ما حبيت يأثر عليها، بس ممكن ساعتها وقت أنت عم تاخذ هالجزرة بعدين يو سبلمنتد أو تستخدم بعدين النون ديستركتيف تيستينج، هذيك الأدوات الثانية اللي عوض ما تاخذ الجزرة، بتسموها جزرة؟
نحن نسميها جزرات في سوريا.
جزرات
باللغة العربية اللي عندها.
أهلا وسهلا. بتاخذ هالجزرة بتفحصها، بتطلع معك المقاومة الحقيقية للبيتون. بعدين ممكن تستخدم شو بيسموه الآلات الاكويبمنت اللي النون ديستركتيف تيستينج مثل الهامر شميت او الوينزر بروب، وتشوف بقى كيف بقي قوة البيتون بالعمود نفسه.
طيب هلا نفسها السؤال هلا نفسه انه الجزرات هلتين اللي عم اخذهم انا، طبعا حضرتك تفضلت انه تؤخذ في وسط العمود، هل هو المقصود هو نفسه كمان بالنسبه للعينات الجزرات كمان؟ انت تو كنت عم تحكي على
الجزرات تاخذ من وسط، يعني الافضل تاخذها، الافضل تاخذها من الوسط.
نعم. طيب شكرا جزيلا دكتور.
اهلا وسهلا. Any other question? Okay, let's continue. I still have 20 minutes and I have few slides to go through, so hopefully I can, I'll be brief. Now, when we have corrosion, what is corrosion? What is first steel? Steel, actually it's located as an iron ore in nature, right? It's iron ore. And how do you make steel out of iron ore? You add energy, right? By adding energy, you create steel. So what is corrosion? Corrosion is the reverse. It's actually that steel is losing the energy and going back to its original state, which is the iron ore. So here we see that by losing energy, steel goes back to its iron ore. And when we have corrosion, corrosion is really expands. So you have the volume of corrosion is about 7, 8, up to 10 times more than the steel bar itself. So when it expands, you have more volume, it expands, it will crack the concrete, and that's where you see cracking of concrete. So in order to maintain steel bars, you add energy. And there are different methods for adding this energy. We have the point anodes, where you have this small cylinder or disc, which has in it a sacrificial metal, usually zinc. You attach it to the bar, and it protects the bar. Usually those anodes have a certain lifespan, few years. And their protection is limited within about 150 millimeters from that anode itself. So it provides limited protection. We have this embedded mesh anode, where you embed it within the concrete, and it provides continuous energy. You have the surface mounted, where you melt a metallic
element and you press it then on top of the surface, connect it to the bar, and then you have this. Here it loses energy, brings it up to that over here, and then it provides energy. That could be maintained up to 10 years. Once that is depleted, then you can reapply it again. Here's another jacketing system. It's the mesh with like plexiglass for protection. Here we have this job where we see, first of all, we talked about how to prepare your surface, that you need to have straight or rectangular saw cuts. This is poorly done. You have those too many corners, ins and outs. That is not properly done. And you see those anodes being placed all around the perimeter and the spacing between them. So there's protection here, let's say 150 millimeters total, but in between there's nothing. And there's also the bars that are inside that concrete are not protected. Sacrificial anode, as mentioned here, we put adding. You can also spray it on columns. That is good for 15 to 20 years. That's another method, and which is obvious. Once that is depleted again, you can come back and reapply it. That is the top of the line when it comes to corrosion protection. It's called the ICCP system, or Impressed Current Cathodic Protection System, where you have this titanium ribbon anode, which is embedded into concrete, and you have here an external power supply. Okay, you have that external power supply. The bars are connected to that power supply, so is that titanium ribbon anode. So once this power supply provides energy as needed, when the bar loses energy, it's being supplemented by the power supply to the bar, so it keeps it, protects the bar from further corrosion by providing additional energy. Maintenance program. So what is maintenance? Maintenance is to restore or improve a concrete structure, its services and surroundings to currently accepted standards and to sustain utility values of the structure. So we as humans, every year we go to the doctor, right? What to do? To do a checkup, to make sure that we are fine. Are we sick? No. But we do what we call maintenance. We maintain ourselves. Structures need the same thing. If you maintain them, they will live longer. If we humans don't go to the doctor on a periodic time or periodic periods, then somebody can get sick, doesn't know it until it's too late. So the same thing with the structures. You need to maintain them. Need to make sure that the structures are behaving or being well maintained. So there are different examples of maintenance operations. You have condition-based maintenance. So after you're doing your maintenance, you find that there is some issues within the structure. You go in and you fix it. Fixed time maintenance. You say, for example, every 2 years, I have to fix and make sure that this structure is working fine. Preventive maintenance, doing it before things deteriorate. Shutdown maintenance. For example, like in plants, automotive, they have 2 shutdowns in a year. They have what we call the summer and the winter. That's when they change operation. So they shut down the plant, and then they go in and they try to find if there's any deterioration or any work needs to be done for maintaining it. The best maintenance program that is specific to your project. If we look at this graph here, here we have time, and here we have the deterioration. In the ideal world where we have concrete doesn't deteriorate, here is that dotted line or dashed line that will continue till infinity, right? That the structure is well maintained. But in reality, we know that structures really have issues. Concrete cracks, we have chloride, we have carbonation, we have corrosion. So if we do nothing, the lifespan of that structure goes very fast, deteriorates very fast. Yellow, that means demolition is warranted. Here we have failure. What I've showed here, for example, I put green, that means structure is fine. Yellow, that it's warning, and red, that means it's gone. So the best maintenance program is that is specific to that structure. Sometimes if the owner waits too long, right, they see some issues with the structure, but they say, my structure is fine. He brought an engineer who's not experienced. Tell him, well, your structure can still be used for a few years without any repair work. So if you wait too long, then the repair work is expensive, will be costly, and the benefits are limited. Okay? Whereas if you start early on, the cost is low, it won't cost the owner much, and the benefits are high. So that's something that the engineer has to really talk with the owner and address it and provide that maintenance program. Early on, I mentioned that the engineer is responsible for everything from assessing a structure to specifying the materials and so forth. Then at the end, I said, and put a maintenance program with the owner to prolong the service life of your structure. So when to determine the end of a service life, when the safety is unacceptable, when structure is not functional anymore, doesn't work, and maintenance cost exceeds resources. The owner doesn't have the money to maintain the structure, then we'll walk away from it and demolish it. Again, there's quite a few documents, ACI and non-ACI documents. For example, you have here the NACE, which is a very good document. You have the SP, TR, you have ICRI, which is the International Concrete Repair Institute. It's our sister company, not our, but it's another company within the US that does repair, but from the practical aspect. Here we talk about cracking, we talk about what you call it, how to evaluate the structure. There, how to do it. Here are some of the like surface treatments, A515, it's a standard. Let's talk about construction work. Construction, it's ways and means. It's by the contractor. The code, it does not tell the contractor how to do the work itself. But there is some interaction between the engineer and the contractor. For example, if there is shoring, the contractor comes in, doesn't know what the loads are. The engineer did the work. He did the calculations. So I mentioned earlier, it's good for the owner to bring the contractor early on so that the engineer and the contractor can talk together. The contractor can hire the engineer to do, for example, to design the shoring. But in general, the contractor has his own engineer, what we call the specialty engineer, who will design the formwork. Okay? So it's good at the beginning for the engineer and the contractor's engineer to talk together to determine what are the forces, what are the stages that are being done during the repair work for designing the formwork or any other thing, any other issues that the contractor needs to put together during his work. When you put the formwork, you have to look at the overall stability of the structure. It should not be jeopardized as far as lateral loading or axial forces, changing in the load path. Environmental issues. I don't think you have these issues here. For example, in the US, there are some structures that were built in the 60s and early 70s had asbestos. So if you open a structure, do you have asbestos there? That needs to be stopped, needs to be cleaned before moving on with your structure because it's hazardous material. It has proven that it will result in cancer. When you're doing your repair, it has to be done properly. When you saw cut, it has to be like 90 degrees. You have to come underneath the bar by about 19, 20 millimeters to engage the existing reinforcement with the new concrete. If you're applying, let's say, pumping in concrete into this upward area, you need to ensure that you have, for example, when you apply the pressure in, to have enough pressure and that your formwork is properly designed to take that pressure. And you need the pressure so that you engage the new concrete with the existing concrete, that they bond properly together. And sometimes you may have another opening. If it's large, you pump, it may set. So you have another venue opening where you can pump in concrete from the other side. So there are different methods that the code doesn't address, but where the engineer or the contractor has to think about. Quality assurance. Quality is very important. You need to ensure that what is being put together is well done, is well built. Because at the end, as we mentioned earlier in that graph from that study, within 10 years, 70% of the repair work fails. So we don't want that to happen. We want to have a longevity in our repair work. Testing and inspection. The engineer should specify in the contract documents what needs to be inspected, what needs to be looked at. The engineer should not tell the contractor, go to ACI 301 and, for inspection, because 301 really has a lot of information, has a lot of issues when it comes to concrete, everything from hot weather, cold weather, all different things. So to tell the contractor, go and do your inspection or do your work per 301 doesn't make sense. So it has to be specific. The engineer has to go to those documents and set in the construction documents what needs to be addressed, what needs to be inspected. Who should inspect it? It's the engineer. Usually the best person to do the inspection is the engineer. But many times the owner doesn't want to pay. Engineer is expensive, right? So they don't want to pay. It's an internal joke, so engineers aren't. So the owner don't want to pay for the engineers to go out and inspect the work. So there could be repair inspectors. So those have to be well-informed, experience in doing that type of work. And currently, there is an inspector program in the US that is being put together for people who are not engineers to be able to inspect that type of work when it comes to repair. Or it could be a combination of both. One thing, once a contractor opens up the structure, okay? He's doing the work, he opened it, and he's now done, and wants to start to close it. The contractor should not conceal the work before giving the engineer a chance to go out and take a look at it and make sure that what the engineer has assumed is actually correct. Because the engineer really did some testing, did some inspection, did take some core tests, but doesn't really has the full confidence that he has addressed the overall issues, or he does not. He may have overseen something, or there may be something that once that is opened, more things have been revealed. So it should not be concealed before the engineer had a chance to look at it. So it needs to be inspected for location of repairs if different, modification of the design, document changes, and so forth. And if there are any changes, needs to be brought to the owner, inspector, and contractor, and the authorities. Non-compliance, if there's any changes, needs to be documented, needs to be shown where those happened, and corrective actions should be taken in case those are severe. In order to ensure sometimes if your repair is properly done, you can take core tests, like here taking 50 millimeter cores. Here that's an epoxy, and you can see here that the work is actually very good work for epoxy injection. If you have, we talked about those transducers and receivers in solid concrete. The path is a straight line, so that is the quickest. If you have a crack, it's continuous. If the crack repair is done properly, then that is also a straight line, should be matching this. So there's other methods to ensure that, that the repair work that was done properly. Test records, you need to maintain those test records. For how long? It's for the length of how long the code, the existing code, or the current code will tell you to do. To keep those test records. For example, the IBC tells you for a minimum of 3 years. But when does this 3 years start? Start at the beginning of the project, middle, or towards the end? Actually, 3 years starts from the end of the project. Once the contractor is done and has, like we say, give the keys to the owner, that's when the 3 years starts. So all the test documents and reports need to be maintained for 3 years or per building code or building officials. Sometimes the building official will say, or the building code will say, I need them more. The IBC requires 3 years. I mentioned 301. 318, when you're doing new design, 318 references 301. That's for specification. When Committee 562 came up with the code 562, they said, we need also another specification document that is specific for repair. So they created 563. So 563 is a specification document specific for repair. It has mandatory and non-mandatory requirements for complying with the repair specifications. So with this, I'm going to now summarize what we talked about today. I think I have still 2 more minutes, so I will summarize. So we said, first thing to do is really gather all the information that you obtain from the building officials, from the owner, from the previous engineer. Then you compare those existing information to your with the site visit to make sure that there's no differences. Do prelim evaluation, and based on that, from that prelim evaluation, either you go on to full-scale evaluation or you say it's fine. We talked about assessing a structure. We do destructive, non-destructive testing. We do the analysis. The analysis has really to follow the as-is condition. And the model has to follow also how we are putting the structure together or how it's being repaired. Putting a criteria for executing the work. Preparing the construction documents. Putting together a, what you call the specifications. What needs to be inspected during the work. The quality assurance program. At the end, you submit a final report to the owner. When ACI was putting this code together, it said it's a new code. So we need to have something to help the engineer with. We talked about educating the engineer about repair. So we thought we needed to have a guide, a guide that will help the engineer understand how the code works. So this guide has the same amount of chapters as the code, chapter by chapter, and each chapter really goes into expanding on the information that's in the code, telling a little bit more information, has examples. Like the example that I gave you here were taken out of this guide. And at the end, it has 5 full real-life examples. It takes you from A to Z how to perform repair. Here I have a list of ACI documents that talk about repair. I talked about tech notes. I mentioned those tech notes are easy, simple, 5 pages, question and answer. All those are available for download. I like this document. I think this is one of the best documents, the 546R, concrete repair. It's very comprehensive, a very good document. It gives the engineer a very good view or information about repair. We have here for education, we call it the E. When you see the letter E before the number, it's for education. It's repair applications procedures. For example, it talks about epoxy. It tells you what needs to be done, how you evaluate a crack, then what equipment you use, how to apply the epoxy, and then with the finishes. Now the committee is updating all those repair application procedures. We have 14 of them. As mentioned here, we have the code and the guide. Now, if I ask you after this presentation, what is repair? Is it art or is it science? Thank you. Thank you. It's both. It's art and science. And with this, thank you for your listening and for your attendance. And I'm available after this presentation for any questions that you may have.
شكرا دكتور خالد على المحاضرة القيمة. والآن التكريم أستاذ أحمد المهنا والدكتور خالد.
الحقيقة نشكر الحضور نشكرهم على فعلا تعنيهم للمحاضرة الجميلة هذه، ونتمنى أن الجميع يعني استفادوا من الكود هذا، ونعدكم إن شاء الله أنه يكون من ضمن منظومة الكودات السعودية بإذن الله. ونشكر البروفيسور الدكتور محمد أحمد الشريم على جهوده في إخراج هذا الكود بالأحرى والتجهيز للإخراج إن شاء الله بإذن الله.
تسلم عليك، شكرا لكم. شكرا لكم. بتحبي الكتاب هلا اعطيه بعدين؟ لا لا بعدين. طيب لا خليك لحظه مع بعض. صح، صوره جماعيه ان شاء الله. صورة جماعية إن شاء الله.